Hello. There we go. And I'm trying to find a good position for this, for the mic here. Hello, 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 Blue, hello, Penguin. What's up, what's up? All right. I did some stuff in between. That was another thing there. Doing a little bit of runic vibe coding in in the meantime here. But man, I have to babysit this Claude. Yeah, so I did a little bit of fixing up here. So now the player is like drawn on the correct place and we can move around. I changed the resolution a little bit. Not sure exactly what it's gonna be, but this looks pretty good. Maybe could argue for like, well, one thing that would be nice is to have it the same, you know, so that you can see like the tiles don't end up that you see partial tiles now. We should see like full tiles. I guess part of it is because we are like centering on the player. I'm not sure, but that's like nitpicking, I feel like, almost. So you can move into town. Can't do anything here yet. We have these borders. However, it seems like the bottom ones work fine. Well, except for over here, I guess. Okay, I thought that it was only like the outer, like the left and right borders that didn't work, but apparently this doesn't work either. It's like a region here that doesn't actually work. So I don't know what's up with that. Is it the same up here? No. Is it the same up here? It might just be down there. Okay, so it's like one right. Maybe it's like in the middle or something. Okay. And these are the borders here. Now I added like a white out or a white rectangle so we can see that where they actually are. So it might just be the collision detection part that is not working properly, perhaps. Because the position is meant to be right. The position is like, man, the position of the body is supposed to be like the center. So actually, yeah, there's a mismatch between render and collision then. I think, in that case. Let's see. I removed the offset on that one. We have a rectangle. That is just a rectangle, so it's drawn there, but the position is probably meant to be the center. So we're gonna take, yeah, it's meant to be the center. Or is it? For the purposes of this game, it makes more sense if things are tile-based. And always kind of align with the pixels anyway. Whatever. Let's just say, okay, P is position minus size over 2. And then we use P there. Okay, and now it makes more sense because, or does it? I mean, okay, we collide. The collision might also be weird, but yeah, now it makes more sense. We can see kind of where the collision are supposed to happen, where they don't happen, and yeah. So right, we should have those be the same. So if I go to where we create the things, this position would be we could just change here. So P is position plus size over 2. And then we change UP. And that should be good. Now it's going to be interesting to see also how the player acts. Okay. Yeah, so here it like collides prematurely. What about top? Yeah, it's the same. Okay. That's weird, actually. I mean, it might not be weird because the hitbox... Yeah, so let's render the hitboxes as well. So we draw position, rotation. Let's also draw a lines. Here. Position is body position. So that's the top left. So we actually have to take the top left of that. So let's get... Actually, we could just get the hitbox. Hitbox of context, because that should just get the body and return that. And then the hitbox we can use to get... Nah, well, let's just do a rectangle like this, because that has all the things in it. So body position, body size, and then here we're gonna say hitbox position is gonna be hitbox top left. Or min. Actually, that's just position. Okay, I need another... Actually, I need another from center. So this is the center position, and then the size. And then position is going to be center minus size over 2. Okay. So now we can do from center position, and then we don't need to do that. So now we have a the hitbox of the body. We can make it into zig+raylib rectangle, line thickness 1, color white. All right. That should draw that around all the hitboxes. And we can see that, I mean, they're off. Because the sprites are drawn not in the center either. Yeah. Okay. So what we do is we go to renderable. And I want to go to sprite. Where is that? Here. And now we do want to do this. There. And now the sprite should be drawn at the correct place. Except, oh, it should be negative. Because the position is center, we need the top left. There we go. However, now you can see that the sprite is like off from the grid. So what we do is we need to change the position of when we create the player to offset by half as well. So we need to offset, we need to basically add like half here. Okay, now the player is correctly placed. Except maybe not. Wait, does this work in all directions? No, it does not. Wait. Yes, it does. Sort of. No? This is weird. Okay, wait. I think it's because the player position is calculated to a cell grid. Wait, this was controllable, I think. Yeah. Right, is blocked. Grid body controllable is blocked. Takes the position. Well, get a rectangle. This should be from center. Oh. That shouldn't change anything. I'm just gonna test to make sure. Yeah. Okay, so we have the... Okay, I see what's going on. We have a target cell that has coordinates. This is a... Okay, that's the target coordinate cell. And we calculate like the top left of that cell. And we set the position to that. That should be correct. I think. Wait, this is wrong. This should be this is using the wrong... Oh. Maybe I should just search for 16 and remove anything. Okay. And here we go. This is the same thing here. So tile size normal. Yeah. All right, there we go. It was the wrong size of the tiles being used there. Well, it didn't solve the issue. In fact, I'm not sure it did much of anything. So basically, we take the rectangle of the player. We set the position to be the target. We check if the target is blocked by looking at all the blocking things. It's like a or a brute force thing here. We go through all things that are potentially blocking, and we're just checking. Okay, are we colliding with this? Which kind of it's like saying, like, let's say we stand here and we want to move to the left, and we're checking. No, actually, this is just for. No, this is just for like dynamic things. Yeah. So here is the actual thing we're looking at. So it must be this function that's wrong. So we're taking the body position, we round it. Actually, we need to floor it now, because position is in the center. Before it was like top left, so it could have like been, you know, nudging between. So we rounded it to top left, but now we need to floor it. There we go. Cool. Okay. Just testing bottom here as well. All right, cool. Yeah, I was thinking, I don't have all these tiles as like blocking entities. That would be really inefficient. But yeah, cool. That works. Now let's fix, I guess we'll fix the position of the town. I mean, we're probably not going to have this world, but what we do have is like the notion of locations, and you can, like, I can just add new locations, whatever. We also have like shared town position, which now we actually need to add 0.5 here, and that should fix that. There we go. All right. Cool. And now this guy is blocking as well. Oh, it's blocking actually more than it should, because we're blocking here as well. Maybe, yeah, okay. The blocking check, I actually need to like round things, because it's not gonna be. Yep. Let's see. So it's going to be a rectangle. Now we also want to kind of round it as well. So what if we just add round and whoops. No. Round void. It's just going to be self position. Wait. This is body. Oh, this is the wrong place. I need to go here. Guess we'll go here. Round. I mean, either we can make it mutable, like mutating the rectangle. We can make it, you know, return a new rectangle. It doesn't actually matter that much. But yeah, I'll just mutate. So then position. I don't think we need to round the size. The size is usually already rounded. So we'll just round the position. I guess, whatever. Round position. All right. I mean, I guess we could just do that as well. We don't really need a function for that. So, but it should actually be rounded here anyway, because we're just taking the coordinates that should be rounded anyway, and times normal. It's probably the other one we need to round. Yeah, this is already rounded, or like truncated, or whatever you want to call it. No decimals. It's an integer. This one is what we need to round here. So we'll take hitbox position. Well, actually, we don't want to round the position. Or do we? Yeah, because it's from center, it like divides by 2. So we probably want to round it. Actually, maybe we just round it. Anyway, like when taking this, if it's a from center, and we do this, maybe we round this as well, because it's kind of the not supposed to. Yeah, sure, let's just round it here. I mean, it depends on the game. You probably wouldn't want to do this if you were not trying to. If you were trying to have like subpixel, or either subpixels or like more fluent motions. I'm just doing this here. Well, it's really just the rectangle that's being affected though. So right. So now we don't need to do that stuff. Okay. Let's try this here. Wait, I'm off here. I'm off grid. Well, that guy is also off. Maybe that is also part of the problem. Yeah, we're kind of centered on the wrong place. So that's gonna be up to the town setup code. And player position is gonna be that. I guess we'll round that. And then I want to add 0.5. That should put the player on the correct spot. Yeah. Cool. Next would be the NPC. And here we just take 0.5 instead. All right. Now the question is, are we still... No. So now we're not blocked in a weird way here. Cool. All right. Great. I want to remove some debug drawing stuff. So let's not draw the hitbox. I could have like enable draw hitboxes. Right. And then what else? FPS, we don't really need to have debug draw. UI. All right. Okay, cool. Oh, and let's remove the border renderables there as well. Okay, cool. So we have this, you know, basic stuff here working essentially, and yeah. So what now? Well, I guess like I'm not sure about like, okay, so what I would like to focus on this session is gameplay mechanics, basically, well, more like combat, I guess. So we need like an enemy, and we need to be able to like attack the enemy. I'm thinking just super basic, like you just walk up to the enemy and you like walk into the enemy to kind of attack, and then the enemy kind of does an attack back. If it's like it's gonna, so yeah, and also, you know, it's gonna be turn-based, so we need some kind of turn-based system to work with that. So, you know, that requires some kind of timing system where it's like, okay, now it's your turn, you do something, everybody else does something, or, you know, something like that. Could be maybe, you know, let's say things have higher speed than you, so maybe they can do more than one thing at a time, so you have to wait until it's your turn, something like that. I'll try to make it super simple. But yeah, so let's do so it's gonna be like turn-based. So I'm thinking maybe we want a system that is like generic, like events happening essentially. Because it would be cool if there was like a text log as well, logging things out that is happening of interest, so you can go back and see, okay, what actually happened, because there could be a lot of things happening maybe, and it's nice to get a log of what's happening. So maybe like an event thing as well. Maybe they can both have, you know, the logs and, you know, information about maybe what happened. Well, we could do like, I'm thinking like start out simple. That's what you do when you don't really know what kind of system you're gonna make. So like you start out simple, you're thinking about, okay, what problem do I have in front of me? Solve that. Unless you've done it like 100 times before, because then you can kind of plan out an architecture beforehand without getting into some pit hole, like digging yourself into holes. And I've kind of done this kind of thing before, but it was a long time ago, like a roguelike timing-based system. I'm just thinking a little bit of how it could be done. We could have like maybe like a list of turns, like maybe like a queue. Um, so if you have a queue, so let's say that every entity has like a speed, and also when they're like previous action, like when they previously like at which time they made like their last action. Because then you can say that, okay, well, and then we'll go through every entity that has like this turn-based, system, like component on them, and look for the ones that are and we like look for the ones that, okay. let's just I want to make a system that is like, I don't know, turn-based turn system. And we'll have a component that is also like turn component, I guess. And you would have some kind of speed, perhaps. Let's just do something there. And then last action at. The thing is, do we want it to be a floating or a integer? Because it's like turns. I guess it could make sense to have it as a floating point, because you could have a speed that is like very fast. You could have like, I mean, let's say it just takes 0.1 whatever time to reach, like for you to do your next move. And then time basically simulates 0.1 time. So everything advances 0.1 time. And then it's gonna be that thing's turn. So last action at, let's do that. Okay, and then the system could have like the current time. So time starts at 0, right? And I will go, so, okay, so what do we need to do here? We need to kind of I think the job of this system is just to find out whose turn it is, and then go to some kind of handler for that entity. If the entity is, the player, then we have to wait for input of the player. But if it's an NPC or, an enemy or whatever, something that is automatic, then we'll, play that, like decide with some kind of AI, what that enemy is gonna do. So this system's job is essentially advancing time until it's the player's turn, is what I'm thinking, essentially. Advancing time and then playing out animations or whatever needs to happen, because you're not just gonna see an updated, like everything is moved. Like we need to be able to see what's going on as well. So we could update the time. The time advance can be instant to the next turn, but when it's the next things, well, next turn is kind of strange to say, I guess, because it's a floating point number. So until it's like the next entity in queue to do something, and then that animation gets played for that action, and then we continue advancing time until it's, and then we repeat that until it's the player's turn, and then we have to wait for input there. So it's kind of like we have different modes, I guess. We can have a mode. This could be like we're waiting for an event. We're waiting to continue. We're waiting for something to happen. And then we can have an advanced mode, which means that we should try to advance time. So here we can switch on the mode. And if we're waiting, we don't actually do anything. Because it could be an animation being played, or we're waiting for input from the player. Hello, Blue. Are you back? Were you gone? Or something like that. So we have to wait for that until we have something we can do. And then we return. What kind of mechanics do RPG have? Do you mean my RPG or RPGs in general? Because that's kind of how you frame the question. So, well, my RPG is gonna be basically like, I don't know. It's the thing. But what I do know is kind of like, well, what you already seen is like, it's a grid layout. You move between like cells in the grid. You're gonna be able to attack monsters, and you're gonna, I guess, try to, I guess, I mean, that's the thing. Like, I haven't thought ahead more than that. Like, I want to focus on the simple things first, like the most basic stuff first. And then we could introduce things like adding maybe equipment. Maybe you get like different weapons to be able to do different like attacks or something like that. You have never played an RPG. I mean, an RPG is like you have a character or a group of characters. It depends on the RPG, but usually, you level up. You get, like, you kill monsters, you get experience, you level up your characters. Oftentimes you can like put skill points in different, skills, like, yeah, it depends on the RPG. Like, there's so many different types of RPGs, but it's like, yeah, that is like, I feel like anything that has like levels, experience, and possibly like equipment as well, like finding weapons and armor and stuff like that. So you can equip different things. Oftentimes you have money, you can sell items, buy items. Oftentimes you have consumable items like potions to heal, things like that. like there's all different kinds of themes. You can have a fantasy RPG, science fiction RPG, pirate RPG. Like there's all kinds. It's a huge thing. You don't recognize any of these mechanics. I'm sure you've seen like levels and experience before. Missing struct field mode. Right, so I guess we'll start out waiting so nothing really happens first. So we have like control over what's gonna happen there. All right. Because we might not always be in this mode, I guess, maybe. Or maybe we do. Okay, but anyway, if we're waiting, we don't do anything. If we're advancing, now we have to... I'm gonna just say advance here. So this is like find the next entity in queue, advance time to that entity's, I guess, like next turn time. Set current, like set active entity set mode to waiting. Okay, so then other things can look at, okay, so that so now the active entity is this entity. Okay, so now we can do this, all these things. You see level experience and ability to unlock that it was a Metroidvania. Yeah, it can be a part of Metroidvania. It doesn't have to be. What's your idea? What is your theme? Can we somehow make it horror? I mean, have you even watched anything on the stream? Okay. I'll show you. Here is the game right now. I don't want to make it horror, no. It's just gotta be a classic RPG, fantasy RPG. I don't want to make a horror game. That's not actually my kind of game. I don't like horror games, actually. Sorry about that. Yeah, so this is, you know, well, you don't really see much here, but if I show you kind of the graphics that I downloaded from HIO. So basically, here are like, for example, like a couple of monsters here. You have like, I don't know, these are probably goblins here that you can attack. Here's like the player, and you can like equip different, well, they have graphics for like different stuff. So I downloaded this for free. So it had, interestingly, I'd actually never noticed this before. All these weapons that you can equip, the monsters can equip the same weapons. That's actually kind of interesting. I mean, that could be that maybe it's like you pick up an item, that's what you have. You kill an enemy, you get the item that the enemy has, and the enemy can also pick up the items. And then what's kind of cool about this, actually, this thing here, is that it does speak to me like fantasy. But it also has space stuff. So it has like space helmet, like robots. It has like ships, planets, guns, stars, a bunch of different planet types, like asteroids and all this stuff. It has like poker cards. It has like a whole bunch of stuff. This tile set. I really like this tile set here. You can basically make anything with this. It feels like that is in this kind of style with like tile-based style, but you can basically make like any theme stuff. Here's like ET, different aliens, Cthulhu or something, I don't know. There's a whole bunch of different things. They just made everything here. Nagas. So really cool tile set. And also like these things, like you can make like logic stuff, maybe puzzles, like a lever here, different things happening, and then there's like, I don't know, pipes, computers. There's like all kinds of different things. Car roads, rail tracks. So yeah, you can make like an automation game with this as well. Cars. And then here's like, you know, medieval stuff with like armor, bows, axes, all kinds of stuff. Like overworld icons here. Really cool stuff. So yeah, just let your imagination go. I mean, I really like this because you can basically take parts of it, do whatever you want, and also add your own stuff. Like, for example, I want to add, like, I don't see too much like magic spell stuff. Here's a bunch of food items, a bunch of like leather, maybe armor stuff, robes, a bunch of different robes. Here's like interior decoration stuff. That's really cool. You can make like a house. When they showcase, they showed like, you know, can make like these little houses in a bunch that you can go into and look at the interior and stuff. And then you have the outside as well. But for like magic spells, I don't see a whole bunch. So that could be something that we can add. Well, here's a little bit. Actually, we have like a magic circle, some kind of crystal ball. We have some kind of vortex portal maybe thing. Mortal. This is like alchemy table. It's so cool because your imagination just runs wild with this stuff. I just really love this. I really love this this style here. Oh yeah, magic scrolls. But I was thinking more like magical effects, like, you know, a fireball like exploding or something like that. Here's like magical staffs, but there's not much in sense of actual animation, which would be cool. But as I said, that could be easily added. Here's a tiny, like a little bit of stuff. I'm not sure what this is. You're supposed to animate this, perhaps. You have a little like magic effects here, maybe. Here's like some kind of circle. Not sure what that's supposed to be. And here's more the kind of mechanical stuff here. And future stuff. So it's kind of, and then and the bottom here, here's a bunch of like icons or something, perhaps different like status ailments or something like that. Yeah, and also it has like fonts as well, 2 fonts. So this just has everything. It's incredible. All right. A really cool tile set, man. It's really cool. Flags for factions. I would like to make an MMO after this. Yeah, so and as I said, like it's also very easy to add things yourself because it's a super simple tile set. The graphics are super simple. So everything is like one color as well. So all you have to do is like make it's like a 12 by 12 pixel with one color. You just make that in the same style, it will fit the style. So you just make something in that style. It's very easy because it's such a small 12 by 12 pixel art, and yeah, really, really nice. Okay, but anyway, let's continue here. So find the next entity in the queue. Okay, let's see if this holds up here. So I'm gonna make an iterator game at the iterator, and we're gonna get all the things that has a turn, and we're gonna loop through that. And now we need to find something. This could be actually a generic function to find something given the thing. And then we say like we get the turn. Component, and we check if last action at, well, let's do that. Next action at can be a function that calculates that for us. So next action at, because we need to find the timestamp of when the next action is like available. So this gives us an F32. This is gonna be last action at plus speed. So speed is actually not maybe correct term here, because I'm thinking of speed as like how much time will pass until we can act again. So it's more like a cooldown, I guess. I guess. What if speed is like, let's say speed 1 means one turn is like when time has advanced by 1. Okay, and speed 1 means something. That means that turn has to go 1. So basically, okay, so cooldown would be 1 over speed, I think. I'm just gonna do this to make sure it doesn't truncate. Because if speed is 1, then it's gonna take 1 turn to do your next move. If you have 2 speed, it's gonna take half a turn. So it's like the factor. If you have, so it will never reach 0. So that's good, because then you have like infinite turns before anyone else can do something. But you can be arbitrarily fast and arbitrarily slow as well. If it's like 0.5, that means you have to wait 2 turns to do your stuff. So we can go both ways. So that's good. So now we kind of now we can calculate the cooldown. So next action at should be last action at plus the cooldown. And we could store next action at instead of storing last action at, we could just store next action at instead. and then we don't have to actually calculate that. I usually do this. I usually store the timestamp that is supposed to be in the future instead of storing the time that you started at and then try to calculate the future where point. So I usually actually do that, but I'm not sure why I did that this time, but yeah, anyway. And then, yeah. Let's see. So we get the turn, and then we look at if this is... actually, we need to find the minimum, so, and there might be multiple. But I think we just return the first, like, if there is multiple, we'll just return the first one. So, because then, or maybe there's like a tiebreaker. No. We'll just return the first one, yeah. So the priority will be probably in the order that they have been created, or the reverse. We'll see. So we need to keep track of min next action at, and we'll start at infinite floating point, yes. Because then everything will be less than that. And then we have min, we need to actually have the context as well. Start with undefined. Unless there are no, that should never really happen, maybe, I don't know. If there are no, can we count here? No. I guess for safety, I'll put this, I'll make this optional. And then in the end, if we have one, then we will set that to be the active. Actually, active could be optional as well. So active context, active entity is gonna be main context, yeah. And we need this active entity is actually optional, and we start out with null. All right, that's what we're doing there. And then we set the mode to waiting. Okay. Now, if next action at is less than min next action at, then we update. So min action at is equal to next action at. Min context is equal to context. All right, and that's basically it. It's gonna iterate through all the things that can have a turn, and it's gonna check, okay, which is the one that has the least amount, and it's gonna return that essentially, and we're gonna get that. We are going to set that here. Now we also need to advance the time to that entity's next turn time. So we're gonna take time, and we're gonna basically set equal to next action, well, to min next action at. Now what can happen here, I guess, is like if I mean, I guess it kind of makes sense. Like if there are no entities that can take a turn, and we want to advance time, and there's no entities that can do anything, we want to advance the time until we find the next one. But if there are none, it's gonna actually set the time to infinite. That's kind of funny. I mean, it makes sense because there's no thing, so it's gonna, you know, go into infinity before actually Well, yeah, that's it. And then we're basically done, I guess. All right. I could make this into a function, make this a little bit tidier. So like find next entity in queue that gives us this one. And actually it should give us the entity and the time. And we're basically doing this. And we'll return entity is min context and time is min next action. And then we will take next entity is gonna be fine next entity queue. I'm just gonna call this next time, next entity. All right. And that's unused. Okay. Whatever. Let's just do that. Cool. So advance will simply find the next entity in the queue, set the time to that time, set that to be the active entity, set mode to waiting, and then other systems can take over to do stuff. Cool. It's a little bit different with like turn-based, like it's interesting to work, I guess, with like ECS with turn-based. I don't think I have done that before. Not sure. All right. Cool. So we can go now to player and we can add the turn thing and we'll just init that. We could add like speed, perhaps. Oops. Speed. Maybe. Could also have like default is just the default there. So either you could do like .default, which is just that, or you can do init with a speed. I guess I'll just do default. Okay, so now we have one thing that has the turn component. I will go to update as well. And we could put... I guess we could do it in the end. I don't know if turn was a good name for this, but whatever. All right, we update that there. There we go. Now the question is, when do we set the thing to? Because it starts out in waiting mode. So we have to kind of tell it to advance the time. So maybe I'm not sure where that should happen, so I'm just gonna start out with setting, like making that happen here. So I'll just get, no, that's this one, yeah. And let's just let's make a function for this. So we have update, advance. I'm gonna have a function that is like not sure what that's called. Let's call this like, okay, whatever. I'm just gonna call this actually advance, and then I'm gonna have a function that's called advance, and this would just set the mode to advance. And then there's a function called actually advance. So this is like the API function that just sets the mode, and this is the function that actually advances. So it's called actually advance. Okay. Right, and now we call advance here. Hello, Hovsetter. What's up? What's up? How we're doing? We're doing good, I think. Let's see where we are. Making like a retro style RPG kind of thing with a downloaded tile set that had a lot of cool different stuff. And right now I'm working on the turn system, so it's gonna be turn-based stuff. You're doing good. Just fixing all the vibe coded shit at work that occurred while I was on vacation. Oh, are the interns having a good time, or is it the seniors, or who is responsible now? I think it has infected. It feels like it's. I mean, because I was in a company that was more like a smaller company. I can't imagine what happened like in larger companies. It's a mix of both. All right, it's the best thing to see. I mean, I still think that it could be like if you can use it as a tool to increase your productivity without sacrificing, like, but you do it in a responsible way without like sacrificing, you know, knowledge of the code, and like code quality. I feel like it can be a good thing. You just have to use it properly, I think. If you can learn how to use it. I think that people are still kind of learning how to actually use it in a good way. And those that kind of haven't, I guess they're just yeah, I mean there are people that just like even before AI slop that just produces code that was maybe subpar. And this just increases the rate of them being able to do that, I guess. And yeah, and I guess before maybe you had time to kind of like direct or yeah. I mean, yeah. It's difficult, especially if you have a code base where you kind of you want it to be a high quality code base. Yes, I agree. If you use it as a tool and still hold yourself responsible for what you produce, I don't really care. But the problem is I'm seeing overall decline in quality across all experience levels. I think it's easy to fall into the trap where you're thinking that the AI can solve all your problems. And it's just like, it's easy to start thinking that, oh, nice, now I don't have to do this, I don't have to do that. But you still have, like, you make the AI do some code, okay, then you test it and it works. Okay, but I think it's your responsibility then, after that, to, if you haven't like followed along, to go in and check the changes, do a code review of your own code. I do that like all the time anyway. And like, especially if you're working with other people, that it's just yeah, it's your responsibility. You're pushing the code, it's your responsibility. So you have to have, because if you don't do that, if you don't look at the code afterwards, after a while you have no idea how the code base looks and what's in there. So if it starts to crop up a bunch of bugs and stuff, and the AI can't solve it, now all of a sudden you have like a whole bunch of technical depth in a sense to like trudge through. It's easier to take it piece by piece than just updating your mental model of the code base. People are producing much more, but the quality is generally worse, and it's because it makes code generation very accessible. I think you need a great discipline to still review everything being produced, and that will also be counterproductive to the feeling of producing code. But don't you have code reviews in your company? So I think it's kind of laid out in a way that makes you more lazy. And if you spend a lot of time reviewing your code, you're not gaining much anyway. I mean, you can. That's what I'm saying. Like, if you use it as a tool, you find ways to make it more productive. It's like AI can be used for certain things, but not all things. Like, especially if you need to like boilerplate or just extend something that already exists. It's pretty good at kind of adding a new thing to an existing pattern or something like that. But if you use it for like everything, then you're gonna run into issues. We do, but if the people who code review are the same people who produce lower quality stuff. Oh, so you're saying like they all vibe code and people who review also vibe code, so they don't review properly? Or because then you have a problem with code reviews, I think. Do you have retros? You should probably take it up. It's funny actually, we had retros in one place, and the retro, they didn't really understand what they were doing. So essentially, we had like stand-up. At stand-up, we just said, what's the progress? What's the progress? Every meeting was like, what is the progress? We have like, stand-up is like, okay, what is the progress of this, of your things? And then like every day we had to report. I don't see the point in that. But then anyway, and then and then it's like, if you have a demo, that's also like, yeah, what's the progress? And here's the progress. You show the progress, and then like that demo is good because you get feedback and you can change things. And then retro was like, yeah, what's the progress as well? It's like, what the hell? It's supposed to be about improving our way of working, not talking about what's the progress. Oh, you had retro Monday, okay. How often do you have retros? I think I guess it depends on the workplace, but in my last company we had like retros like once every month. I felt like it might be a bit slow to make changes, because before that I was used to having retro every second week, every other week, just like end of sprint. was like, it was 2-week sprint, so end of sprint was, you know, planning and retro and that. I guess, yeah, it depends, you know, the need and all that. Okay, cool. So you're the high level programmer complaining about this shit coming in. And yeah, man, yeah, I feel you. It sucks when you have to live it and work with that stuff. I bet the vibe coders feel great though. Do you have, so okay, how do you do it? Like, let's say a bug comes up and it's like, do you try to track why or who is responsible? Because I always felt like it's like a, I don't know if it's a good thing or bad thing. I'm not sure. Because it's good in a sense, because then you get the person who might know the most about it to solve it. But it also is like, so it can feel like a witch hunt. I have a pretty high bar when it comes to quality in general. It's obvious I just ran with it. Well, wasn't I? Okay. All right. Do you have a set like required code review that you have to code review everything? I don't necessarily try to find a blame, but usually you know based on the debugging to find the source of bugging. Okay. Yeah, but then you're actually solving it though yourself. Well, I guess it's hard to find the reason of some bugs, so without actually debugging it. But it could be like based on like area, you know, application area. But anyway, cool. All right, so there was no issues here, right? It just, there's some weird like moving around in the beginning. I'm sure there's like one frame of like things looking very strange. Okay, well, anyway, what we want to do is we also want to we want to pause the player until it's our time again. And then we're waiting for some input. And then we want to advance the time to the next one. The vibe coders are on vacation. Okay. I mean, I don't necessarily try to find it. How did the TD experiment go? I put it on hold for now. I ran out of interest a little bit. I wanted to. It's like Storm of Life. It's like you run into some blocker and I just run out of motivation at some point, and then a new idea comes into my head and I start something else. But this time I want, so the purpose of this project here is to create a small game as I can that is like, but still complete. So it's gonna be, you know, a complete game that you can potentially put up on places, you know, itch.io or whatever, Steam or whatever. And yeah, I've decided to just make it like a very low ambition game, but it's gonna be like a complete game. So, and it's gonna be, I'm picking like, you know, a genre that I enjoy and that it also feels like kind of easy to implement as well. No physics stuff, you know. Classic, I'm guilty of that myself. Yeah. it's like, yeah, it's like kind of sad actually that I think many people actually are like go there. But I do have a long running project that I return to every once in a while and make progress on. So it actually it's like it's nice because you also get motivation to continue a project if you have if you got over like a hurdle. Okay, let's try to make something here. So, because then you can look back and you can like see, okay, I've gone this far, so that's really nice. So it gives you motivation to keep going. So I think we need to go to like here, but perhaps. And it's like instead of, so we do already have kind of like, you know, you can't do anything if you're currently moving logic. So here, well, not this one, because I don't think we're actually using that, but this one here is like, if this is more than 0, that means we're currently like playing the move animation. So then we're actually doing the move here, and then we're done. I think we need to move this logic into like a move component or something, because yeah, it needs to be its own thing really. And I've been thinking of maybe like having a component like interfaces. So for example, like let's say we have a move component that handles this movement, because that's going to be like generic over all things. So it's not just the player that has this, it's going to be everything. So move that out to a more generic component, and a system as well. But then that's also part of like a larger concept with like actions that you're doing. So move could be an action. But the problem is in this ECS library is that, and I guess with Zig as well, is like the components are, you can't, like there's no way to kind of have like an interface like built into the language. So the way I'm thinking about it, so basically we would have two different components. We would have one that is like action, that is like just a like an interface essentially that could potentially have interface like generic functions. Like for example, it could have like how long does this action take, for example. Like it could be like each action takes like different amount of time maybe, so the action could have that. But then we have like implementations of the interface, which could be move, for example. That could be an implementation of the interface action. So but then when you use the ECS library to kind of query for these things, you have to query for, you know, you can query for actions, like everything that has an action. You get everything that has action, but then you can also query for things that have movement, since they're two different kind of components, but they really also are, you know, one is the interface of the other, and one is the implementation of the other. So they become kind of coupled in that way as well. So I'm not sure exactly how that could look. I have an idea right now that I could try out. So for example, if you create a component called action, what we could do is we could just say that so this is the generic interface. So let's say we have like duration, for example. And then this could take like, either we could take the implementation directly, we could also take, because we can't store like a pointer here to the implementation, because those pointers are not stable. We could store, I guess, the context, but that doesn't really make sense. We could just pass in the context here. So we could pass in the context. And then, for example, like let's say we make the move component as well. And so we have move. Let's say, I guess we could have like, so this is essentially like move action. It also has like the animation stuff in it. So it's gonna have like the counter, which I guess that could depend on like the speed. Maybe this should be maybe like the distance to how much you need to move. We probably need like direction. And let's just say this is task size normal. We probably need to int from float as well. So that's gonna be like one tile, essentially. All right. And I guess, but then the duration is more like that's more like a gameplay like duration. How much turn time will this take? I mean, we don't really have this right now. I just wanted to make like an example. So if, let's say, we have a direct or duration implementation function here, and let's say we have like return like F32. Actually, this doesn't need to be a pointer. And I guess let's just return 1 here for just to do that. Now the problem is, how do we get the interface here? That is the issue. That is the issue. Unless we like pass it in. We could pass in the implementation as an any type and then just return implementation duration. But that kind of defeats the purpose a little bit, because what I want is basically I want a query on action and then use these functions to get like generic action stuff on it. And all as well being able to query for move specifically as an action. As well. I mean, one way would maybe be to embed. The problem is we can't. No, that doesn't work. Because I was thinking of making this like a union enum and have like the move, like all different kind of actions on here. Like that's also one thing you could do. However, then you can't really query on just move actions. I guess it doesn't really matter that much. Like, the thing is, I don't think we need to worry about performance too much here, since we don't really have like physics stuff going on. So just having like a switch on action every time, it doesn't really matter. Okay. Question is, can this work? And the thing is, like, you also, if you had like, let's say you had a generic, so you had like a com time t, this does not work either, because each action will then, like, if you put like action, like you try to add like action move, for example, then sure, that will add it as a component, you know, left or whatever, that will add it as a component. However, the problem is, when you query, so you want to like do like game and the iterator, and you put in, let's say you put in action, that doesn't actually work. You can't get all the different actions, so you have to kind of do this. So then it's like, it's not actually generic. Yeah, you can't query generically. You cannot query for action like this. I mean, I guess one thing that we could maybe do is we have like an action type. But then we have to kind of define all the actions here. We also have to have a map to get the action out. So like get inner or something. I don't know, get implementation. This gives us something. It depends on the thing that we have here. So like, let's say we have well, yeah, this is action. No, this is self. And this gives us the problem is the type here, the return type, because we can't just say, well, I mean, you can pass in a type as well, though, I guess, but then it also kind of defeats the purpose. So let's say we had, let's say we have t. Now we can say return, you know, switch on self type, and if it's move, we will return, also we need like context here as well. Also this could be pointer here, so we need context. So this would be like context get t, you know, or well, if you already have t, then we actually don't need to switch here. But yeah, this would be like, you know, move here, for example. And then down here we could say implementation is get implementation, and we return, we call duration there to get the actual duration, for example. So then when we add the action component, we also specify a type. we could have like an action in it, and we simplify the creation of the action. But now the generic doesn't work. We can just, that does not work. This could work, but I have to fix some stuff. And then I also have to have like triggers to like remove the action if any of the sub actions are removed. We need to also remove action as well. Self. Right. So the only thing we need to worry about is this one now. I mean, you can pass like any opaque like this. The problem is now we don't know what type we get. So we can't actually get this and call stuff on it because Zig won't know which function to call. What you can do is, as long as we have self and we pass, like we put in this type, we can actually convert it to a type. So we can actually say implementation, we have a function implementation, we pass in type, but then that has to be comp time, maybe. Let's see, we have implementation, and let's say we have comp time. Well, it's not comp time. So this is gonna be the type, action type. Well, we can make it comp time here, but this is returning a type. So we're gonna switch on action type. We're gonna have an inline else. And this, and we'll return. And this is now the type, comp time. And now we can say, well, I don't think it works because we're going from runtime. Well, yeah, I don't think this will work, but let's try it anyway. So we need to map this to a type. This is essentially what we're doing here. So actually, I'll just put move here. That's gonna be move. Yeah, we just have to define the map here. So every time we want to add a new action, we also have to go in here and do all these things. I wish there was a way maybe to not having to do this. I don't know. The only thing we really gain from this is the thing that I'm talking about, like you can query for all actions, or you can query for their implementations, like move. That's the only thing, that's really the only thing you gain from this. You gain like a generic way to talk about actions. Which is cool, but is it worth it, all this stuff here? I don't know. Let's try it. So, but I don't think this will work, but I will try to make it work here. Get implementation. I mean, really all we need here, actually we don't need self. We actually just need the type And we can kind of make the type sort of comp time. Let's try it anyway. Okay, so let's move. We get the move. We will. This is not type. This is action type. All right. Could you do like inline switch? Is that a thing? No, that's not a thing. You could do it inline cells here, but another way to kind of do this is if the type was a union. Nah. All right. And now gets implementation is instead self type. Now there's a way to turn this into a comp time like this, and then I'm sure this will work. However, then we need to kind of every time we call this, we kind of need to turn it. We need to turn type here into comp time by having a switch on self type and then an inline else that kind of does that thing. If this doesn't work here, but let's try it anyway. Okay, so now we have this kind of generic thing. This has like an implementation here, and I'm thinking also probably this type you could potentially have like, say like interface is gonna be action. So that way, when this gets removed, we can add a hook to when this gets removed. Check if it's move, or check if the type of what was removed has an interface. And in that case, we need to remove this interface as well. So that could be a thing that could be done. So I'll leave that in there for now. But now I want to create a system for move. All right. And we're gonna take, so we're gonna say iterator. We're gonna get, so now we can do this. We can get move, all the things that have the move action. And we're gonna iterate through that. We're gonna get move. And do the same logic that we have in here, where we basically do all this. And that has to be counter. We have next move at. Right, so we need next move at as well. Now this is an actual timestamp like this. And the speed could be also, I guess, on the move thing as well. Sure. That's how many pixels we move per frame, I guess. We have direction. Yeah. We also need the body as well. And here is like, this is specific for the player here. So right. All right, we have duration as well. Like real-time duration. Which is what? (0.025). Okay, we can also adjust that to increase the speed, I guess. I was trying to increase the speed by doing like every frame, but yeah. All right. Cool. So this is gonna be the real-time duration. All right, but this part is really going to be only for the player. So I'm thinking about how to actually do this. We could potentially have like a hook, like an event happening, maybe. Like saying like, okay, now the move is done. Or, well, yeah, because if move counter is 0, if we go to controllable, try to check like is move counter 0, it's gonna be 0 most of the time essentially. This is only 0 if we're moving and we're moving into something and then arrive. So if we can capture this notion here, we can say, well, actually, we could just set a flag on here, I guess, to say, now we have arrived, perhaps. The problem is if there's multiple systems trying to look at this. Either it has to be the same frame, or if there's multiple things looking at it, consuming the value. Or we can just have like an event system where we have a hook. Someone listens to this event. It's gonna be happening here. We can also have it so that the event, like we can actually have like an event system. Yeah, and then like listeners, we add the event here. And then we're gonna process all events at the end of each frame, I think. Because otherwise there could be a lot of weird stuff happening like in between. weird states and stuff like that. Yeah. Let's make an event system. Event. So the thing is, you could, like, let's say you would have multiple events. In this ECS system, you cannot have more than one event. So I guess we would have like an event, like for the components, we would have like an event container, which has like all the events here. And these are just a list of events. Yeah. So these are not sure what to call this. Entity event. Okay. And that this could be an event, probably a union enum of some sort. So one event then would be move done. So move done. And it could have a payload. I'm not gonna add a payload right now. We'll see what happens. But let's put in this list of events. And like, if we don't have a value, question is, do we even need to allocate this and free it? That's probably good to allocate free anyway. Yeah, let's just do that. Let's go. Well, actually, you know what? It can be an array with max events as well. Whatever. Let's just have a deinit here. This allocator. Okay. And we'll just free self pivots. So now we have to make sure that the events we put in here, well, what we can do, I guess we put an, if we have an allocator given to us, we can just dupe it. All right, and then I'm just gonna catch a reachable here. All right. Yeah. Oh, speed. Oh, speed is from move, right? Cool. So we have, so that's the component event. And then we also have the event system. The event system is going to, like, okay, the thing about the event component is like, it's like attached to an entity. Maybe there are events that doesn't like attach to an entity. Maybe they are like global events. So these events could be for entities only, and then you could have global events here if you want. I don't really have that right now, I guess, but what we do want to have is we want to have listeners that are listening to, like, a dynamic list that's list of listeners, of functions that is going to listen to the events. Actually, it's going to be a map, hash map. Let's do that, and then it's going to be Actually, unmanaged. Let's do now let's do managed. Yeah. So a hash map of this is gonna be event entity events, and the value is gonna be event listener entity event listener, where an entity event listener is a function to, or a pointer to a function that takes perhaps the context and the event yep, and yeah, that's it. That's what you do, and you return a void. Okay. And init needs an allocator. And so we initialize that. All right, and now we have a init function. Except we don't need allocator there. Okay. Cool. Let's do auto hash map, because otherwise we have to fill in a bunch of functionality. Auto hash map will kind of, because you can customize how like it's gonna handle the keys and the values and all that, but auto hash map will like try to automatically understand what to do. Cool. So as long as you have like a simple thing here, like a union enum, for example, or just an enum, really, it should not really be an issue. All right, so we need an allocator. Let's just pass in that there. Did I put this in update? I don't think I did. So we have turn. Let's also have events. And here we update. There we go. All right, cool. Actually, maybe this should happen after here. We could do turn at the end, this after event, because potentially things can get destroyed. And we wouldn't want to like go one more frame with all that stuff. Yeah, let's do that. All right. So, let's say we have listeners. Let's say we need to kind of, so this is going to get called at the end of each frame, essentially. So what we need to do is we need to iterate through all the things that has event components. So let's do that. Event. And we're going to loop through everything. So context. And we're gonna check. We're gonna get the event container. I'm gonna call this the container. And then we'll loop through the actual events, and we are going to call, we're going to get the listeners for this specific event type. So this is going to be self listeners get, and the key is going to be it's just going to be this, actually. I I'm just gonna double check, because the thing is, like, the key is not supposed to be the actual union enum with payload. It's just gonna be the tag, actually. So if we do like tag of this, like, I'm not sure if auto will think that has unique representation. Yeah, it's just gonna like take the whole thing. It doesn't do some weird stuff. So yeah, let's just take the tag of entity event, because now we're kind of stripping out the payloads and we're only dealing with the enum. Okay. And now I'm pretty sure it's gonna coerce here, but we'll see. Okay. So now let's see. Now we'll go through each of these. Oh yeah, and if this can be like null. So if this doesn't exist, we just continue, because then we don't have like any listeners for that event type. But we can go through each listener. So now this listener. Oh, I'm not sure what happened there. This is now. Oh yeah, wait. This needs to be a list of listeners. There we go. Actually, it needs to be a dynamic list of listeners. Yeah. So actually it's going to be listeners.items. And now we have the listener. And now we just call the listener with context and event. There we go. So now we are like calling the listeners, but we don't have a way to actually add a listener. So I'm going to say on and we're going to have the event type is going to be the tag of entity. You know what? Let's actually just, what we can do is just make a tag this that actually is the enum. I feel like this is more proper way to do it. And then you can simply put the enum in here instead of saying enum, because enum just creates a new enum. Now we actually take an existing enum, put it in here. And if let's say I add one thing here, well, I don't get the error now, but there's supposed to be an error, so you have to kind of add the thing, you know, it has to match whatever the tag is. So they are the same. And instead of doing this, now we can just say tag, which is really good, because then we also get like auto completion and everything for that as well. So on, instead of doing this, we're just gonna do event tag, and then we have the listener, which is entity event listener. Okay. And now, also, I probably want to make like this managed as well, so we don't have to deal with passing the allocator every time. Or we could store, I guess we could store game here as well. Game should be stable. Like the pointer to game should be stable. I think it definitely is actually. So actually, let's just, when we do this, we just pass in game. And this would be game.allocator instead. And set up systems, here we pass in game instead. Okay, cool. So, yeah, and then we have to actually store it here as well. And now actually we don't actually need game when we update because we have it on self. Okay. So, back to here. We are going to say, we could do like if listeners contains event type, or if we don't contain event type, then we are going to put a new entry, and that entry is going to be just init, well, it's just empty, yeah. So there we go. Now we have initialized that dynamic array there in the hash map. And now we need to get the array out. So I'll just do this. Get pointer to event type. And we know it should exist, so I'm just going to unwrap it there. And then here we're going to append. We have the allocator, and we can append this listener there. And I'm just gonna catch unreachable on these things here, because you are also yeah. Okay, so now we can actually add listeners here as well. Now we could also add like remove. Let's just do that so it's complete. So I'm gonna say just off. We have the listener, which is a pointer. It should be, you know, identifiable with itself. You should just be able to like equate the pointers to be able to tell if it's the same function. So essentially we can just pass in the same parameters. We can say, well, if we don't contain it, actually what we can do is just say, okay, well, if we have listeners, we want to get the pointer to this event type. If we don't find it, we don't really need to do anything. So then we just return. That's could be like, you know, could generate an error or something. All right, Hovsette, have a nice day. Thanks for stopping by. Hello, Perido. What's up? All right, so we have the listeners. If we don't find it, we return. And now we can do like swap remove. Now this will change the order. I guess we can do an order move because we're not going to have a huge amount of things. So there's two ways to remove from a dynamic list: the swap remove and order remove. Swap remove is like the fast version, but it does change the order of the items because it removes the element at the specified index, and it also returns if you want to use it. And where the empty slot was now, like at that index, there's like an empty slot now. So it needs to be filled. So it takes from the end of the list and puts that item in place, and then just reduces the length of the list by 1. So that's a really fast way of removing the thing, but it does change the order. I don't think the order of operations matter that much, but just to be safe, you could do an order remove instead, which will be slower, but it will keep the order there. So yeah, let's do that. So order remove takes self and then just the index. Oh yeah, we actually need to find the index here. So index is gonna be find or index. Wait, no. It's actually in another package. It's standard mem index of scalar, and then this is an entity event listener list, and the slice is going to be listeners items, and the value that we're looking for is the listener. So this will give us the index of that listener if it's in there. If it's not in there, we don't need to do anything. But then we find it, we will remove it, and that's it. Yeah, and then you cannot be an error, so we don't have a catch here. But you do return the thing, so but we don't care about that, so we'll discard it. All right. Cool. But then I want to do one more thing. And I want to check, just to keep things clean here, I want to check if the length of the items is 0. If it is, then we want to remove this from the hash map here. So remove event type. And that should work. Bool is like if it existed or not, I think. It is deleted from the, yeah, if it finds it, it's true. So we should just be able to remove it, and there we go. Also, we should actually deinitialize that thing. Now, you could, for optimization, you could keep it around. I'm just doing this so that we get like a more safe execution here. So we'll just make sure that well, actually, we don't really need to do it like this. No. We could keep it around because yeah, that's it. I guess we could just keep it around. It doesn't matter. I was thinking like something here will go wrong if we don't find, if we have like an empty list, but I don't think so actually. Because when we add a new thing, it's just gonna, yeah, it's just gonna append it. That's fine. If we're here, we won't find any listeners to do anything with, so that's fine. Yeah, I don't think there's an issue with that actually. However, we do need to do something here though, because this just deinitializes the hash map. We need to deinitialize every item as well. So what we'll do is we get an iterator of the values, and we'll iterate through those. And here we get like the actual list, and we deinitialize that as well with allocator. And there we go. Now we should be fine there. Okay. And since we have a deinitialize on this, now we also need to add it to here as well. So we need to get the event system, and we need to deinitialize it. There we go. Otherwise we get a whole bunch of memory leak reports. Okay, so there we go. Now we have this event listener system. We can add any arbitrary like events, well, anyone that is, you know, defined over here. We only have one event right now, but we might have more maybe in the future. And we can add listeners to those event types, and we can then, and then we are fetching out the listeners, we're calling them for each event and listener there is. So let's see if we can put this into practice now. So let's go to now. Yeah, so now we can do, oh yeah, I forgot one thing. I forgot another thing. How to actually create, like emit events. This could be something like on the game, actually, on the game structure here. So I'll add a function that is like emit event. And let's grab self. We also need the actual event, which is gonna be an entity event. And we also need the context to emit onto. I guess this could be on the context itself. It's such a general thing that we could probably put it on the context instead. Where is that? Here. Yeah. Now this doesn't need to be a pointer. Turn void. All right. And now we don't actually need this context here. Cool. So emit event. So first we need to get the event container. Oops. And if we didn't find it, we need to actually create it. So I'm just gonna do like or else add event and init, and the events is gonna be just this one event. Actually, I'm not sure. Do I need to allocate that? Probably. That should be like a runtime thing. Yeah. Actually, no, because it's gonna get duplicated. Yeah. It's gonna get duplicated. Cool. Oh, thanks for the follow, Ledio Loki. What's up? What's up? Hopefully, I pronounced that in an acceptable way. Okay, so now we have. Welcome, by the way. How's it going, everyone? What are you doing? Okay, so we added the thing and now we actually have the event. So we don't actually need to do anything else, actually. So if that happens, we do this and then we return. Okay, otherwise we have the container. Now we need to append to the events. And I see the issue here because we need to append to it. So actually it's better if this is a array list, a dynamic list here of entity events. All right, cool. Now, this could be init. There's like from own slice, yes. From own slice. I'm just gonna double check. Do you do anything? No, you just take it over. So duping is correct. Are you? You're not doing anything error-y there. Cool. So we're creating this dynamic list now instead. And now we can say over here, we can say events append. I mean, we could also do like an, we could do, yeah, let's, I'm just gonna append here, or emit, actually, event, just so we don't have to catch unreachable everywhere. So there we go. Cool. So let's just call emit with self game allocator and event. All right. Cool. Right, and now you have to say .items. And also we could add, yeah, now this is wrong. So we have to do the initialize allocator instead. There we go. Okay. What else? So, also here, yes. So when we go through events that have been created, we call all the listeners. I forgot one thing. We have to also clean up those events. So essentially, we kind of just have to remove all events. Essentially. So what I'm gonna do is I'm going to loop through this again. So you can reset the iterator. I'm going to loop through again, because if I remove them while iterating, there might be some issues with the iterator. So well, but now I'm iterating again. Okay, let's do this instead. What I usually do then is I am going to say I'm going to say actually, is there a way to kind of remove all? No, remove all components from an entity. No, I just want to remove like all components, like one type of components. I guess that might not exist. Okay. So okay, let's do like, so I usually have like events to remove. Let's just store these as context, so we can remove them from the context. Okay. So all of this happens. We add it to here. And this should be just context. Then we go through the items, yeah. And now we can remove event. But we also need to fetch it because we need to call the initialize. All right, and then in the end, I'm also gonna defer the initialize here as well. All right. Cool. So now we're cleaning up the events every frame as well, because we're processing through all the events. They shouldn't exist next time around. So there we go. And after all that, now we have this infrastructure of events. So now we can go to the something that I forgot. Move thing, yes. And now over here, we can emit an event on this context, which is the thing that is moving. And we can emit an event, which is move is done. So there we go. Now we can emit that. We'll remove this code. And I'm going to go over to the code that was, no, systems controllable. I'm going to go over here and we are going to get, no, actually, this should happen. Actually, now I need like a setup function actually. And this setup function will take game. So we need some stuff. Actually, what we could do is we can have like the event listener stuff here as well. So this will be convenience function here to just add event listeners. And it would be the same thing. So we would have event type is tag and listener is event entity, wait, event entity event listener. There we go. Void. And now here we'll get the event system and we'll call on this one. And there we go. And we can also do the same for off. I have this copy in my so I don't want to like copy. So there we go. In my copy buffer thing, this thing here. Okay, so then, so now we can say just on, whenever we have a move done, we want to say on move done. Okay, and then we have to go and have that thing somewhere. On move done takes the context and the event, which we don't really care about because it's just an enum. So and this event even is like an entity event move. I guess we could still like have the type there. But let's just make it a void. Okay, and now we have this code in here. So when move is done, we are doing this code, which is doing stuff. We need body as well. And we need to say that, and there we go. Then we should be done. Cool. Great. Except one more thing. It should only affect controllables. So we should also have, this should be like a filter actually. Or we should apply kind of like a filter. So actually we need to do like if, because this is going to happen on all things that are moving. So we have to, for this one, we actually have to add, it has to have controllable, which kind of means it's the player. If it doesn't have controllable, we don't do this. There we go. And now we have to go up to update, and I will basically just return all this crap here. Important to note though is that if we're currently moving, we should not do all of this. So it has to be the player's turn to do all this. So what we're gonna do is we're gonna get the turn system and we're gonna check if the active entity, we're gonna get the active entity. If there is no active entity, we don't do anything. Then we're gonna say if active entity equals, oh, there's no equals function. That would be a good thing to have. Equals other food self entity index equals other entity index. There is also a version. I don't think that will ever happen. I'm just gonna compare the index. It's gonna be fine. So if this is equal to, or equals, I'm not sure what it's gonna be called. If this equals, yeah, if active entity equals context, then, or if it doesn't equal context, then we continue, yes. So really this should kind of happen first, because that's checking like, is it our turn yet? If it's not, then we don't do anything. When it's our turn, then we can do things. Okay, so now we've kind of connected this part to the turn system. So now we have turn system getting activated first. It's gonna advance the time to the next thing, which is gonna be the player, because that's the only thing that exists right now. Then it's going to go to wait. And then the active entity is going to be the player. So this is going to get true. And then we're going to be able to move and do things like that. And then we move. As soon as we do the move action, that's going to play out the action. When the action is done, we actually then have to advance as well. So that is also important. This is actually not enough, I just realized, because this only checks if it's our turn. It doesn't check if we're currently doing an action. If we're doing an action, then we should also not be able to do anything else at the moment. So the question is, how do we do that? Where do we do that? I mean, I guess we could just check if we have an action component on us. If has action, and this is when it's actually really nice to have this as an interface, because we could just say, do we have an action on us? Doesn't matter which one. Then we continue. Okay. Nice. Okay, so now we need to do some stuff. So basically, the move counter is not gonna exist on controllable anymore. So I need to move this logic, or remove this logic, and essentially, yeah, we don't need to get that thing. Yeah, okay, now it's time to go to the enum, and it's time to do this thing now. So this is gonna be action init. It's an action init. Sorry about that. And this is gonna be action init, and usually like a union enum. So let's say, for example, we have like move. What do we need to create a move? I guess this could just be the payload. So like action, or actually, you know what? Yeah. So action get implementation, and it's gonna be the move. Wait, why do we need context? No, not get implementation. It's gonna be impl, which is not public, so let's make that public. Impl. Impl is a function, so we need to pass in move. There we go. So now we're actually calling this function here, and we don't get, well, we're not actually calling it. We're calling it kind of come time. So right, and then we need a custom add function. And we're gonna say, well, first we're gonna add the I'm gonna get some more coffee here. Be right back. All right. Of course, we want to add the action, and the type is well, I mean, it depends, I guess. Oh, thank you for the follow, Danny Vortel. Not sure how to pronounce that. Welcome, welcome. How to get the type, the type. We could... No, this just gave us that. We could have like an init as well. I guess as long as we have the action. I mean, essentially what you wanna have like an if or less a switch. I mean, and if we have move, then we're gonna add the move. Let's just do this like this here. We want to add action move. Yeah. But we also want to add the actual move action as well. So this is what I meant with like kind of like an interface. It's like you add, if you want to add this specific implementation of the action interface, we add both components. So now you can query on either one. And then I have to kind of add some harnesses stuff for like if one of them gets removed, we remove the other. And when we add them now, we add both together. So they're always like together there. Penguin and Dunnevorter is the same person. I don't think so. Follow 74 software and game development streamers. Nice. By the way, I just came to a really nice eureka moment where I realized you can actually, if you want food to last longer, you can actually freeze it. All right, so I bet you didn't know about that. Move needs some stuff. Well, that's just gonna be this. Yeah, that's gonna be this. Yeah. This is the payload. Let's just call this the payload so we don't have to change it. Oh, wait. We could just do that, actually. Yeah. What is this black magic? Yeah. I had this, like sometimes we do like tacos, and we use like minced meat mixed with black beans. I'm not sure what that's called. And some other stuff. And usually there's like leftovers that last for like in the fridge. It lasts for like a day or something, or a maximum 2 days before it starts to taste funky. And I usually just eat everything the next day, but sometimes there's like a lot of leftovers. And I was like, wait a minute. Hang on. There's this invention where food lasts longer and it's even colder than the fridge. Genius moment. All right. And you can salt it. But yeah, then it's, yeah, I guess if you don't mind the taste change. Okay, are we done here? I think so. So yeah, now is also like one more thing is like when we remove action or move, it should remove like the correspond like the other one. So I think if we go to setup and let's go to perhaps, I'm gonna like let's add it here maybe. So import, no, what's happening? It's gonna be self registry, and there's a bunch of event listener here. So on construct will be like you can register event listeners on the ECS system whenever a component is created. That is on construct, I'm pretty sure. And then destruct is when a component is removed, or yeah. Update, I actually don't know. I don't know what this is. Well, whatever. I know that I want destruct, and this is going to be whenever. So now we actually need to put everything in here. That is unfortunate. You know what I'm gonna do? I'm gonna go to action, and I'm actually gonna, instead of having this as like a function, I'm just gonna make a union enum here, which is like type with payload. And this is a union of type. And I'm just gonna define it here because then I can use it in comp time to reason about it. So move will be game scene move. All right, and then we don't need this function here because now we can just say, well, just adjust. I mean, I guess we could still have the function, I guess, but actually now we can do like inline else action type. No, we can do, well, yes, I guess. So we get the type and we'll do like type info. No. I mean, I guess we can. No, there's like standard meta field info from type with payload. The field is T, because that's the same enum, so that should work. Yeah. And then this is now the field info, so we can get the type out from the field info like this. So there we go. Cool. Yeah. And then so now we can do like on the struct, I'm gonna add like action. When action is removed, we need to remove, so on destroy or on remove action. And then the thing is like we need one for every action implementation. So we can do an inline for of action dot tag with payload. However, what we want is we want the tags. No, well, I guess it doesn't matter. We could get the tags here to get the tag there, and then we can say self-reg on the struct game c. Well, actually, this is gonna be the, well, yeah, action payload. No, wait, we can do fields. Yeah, fields is better because then we have the type directly instead. We can just say field.type. So that will be the thing. And so when that is called, or when that is, yeah, when we destroy that one, which is move right now, that's the only one we have, we're gonna do like on remove action implementation, because those are gonna be different things depending on what we're doing. So now we need those functions on remove action. What is the difference between else, for, etc., and inline else, inline for, inline, etc.? It's just to look cooler. Like more code, more keywords equals like, it just looks more. No, it's so the difference between else, for, okay, yeah. So basically, I mean, you know, you have if else. This is pretty simple here. It's like this happens if this is true, this happens otherwise. That's the else there. You have switch something here. Something happens here, and then you have else here. So basically, this is like, well, if this matches, then this happens. If none of the cases happen, so let's say we have like ASDF, if none of these cases happens, then this is the fallback. It goes back to if this is the fallback. So this is just a normal switch here essentially. Now, if you, let's say you have like well, let's say you have this tag here that we have. So type. So this is an enum. It just has one move there now. But if you do inline else here, what you get in the capture, so is like it's a comp time version of this tag. I'm gonna answer you in a second here. S for game clown, which you can then use in comp time to get things like calculating types or doing things like that. So this will create like one branch for each well, now I'm switching on the type. You can't actually do that. You have to have like a, let's say we have a thing of that type and we're switching on that actually. So what this will do is the inline else will create one branch for each of the enum variants. Since we only have one in this, it's just gonna, so essentially this is gonna compile into you know, switch, blah, 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 move, then we do something, and so on. So it's like an exhaustive, like, you know, check for each variant that S can be, essentially. And you get one branch for each of those. Not sure if I make a whole bunch of sense here, but and then you can see the difference here is like, let's say we add another one which is like attack. Okay, so now all of a sudden this gonna compile into this, so you get attack as well. And why would you want to do this? Is because you get a comp time like tag type here that you can use. So you can basically have like different things happening. So let's say that the tag is equal to move. If you add comp time here, it's gonna be compiled to this code if it's move. So this is essentially no difference from just saying move and have this thing happen here. But you can do like more generic things with this. So it's kind of a way of like generically talking about all the tags at the same time. And yeah. So, okay. And then the last thing is going to be the inline for. So let's say you have a list of numbers and let's loop through those. Okay. Actually, I can do like compile load maybe. Right. So what's this gonna do is it's going to, oh, we get like a bunch of errors here because I haven't done everything here. Let's just do this, see if we can get this error here. No? Okay, whatever. So what this will do is, you know, it's a normal for loop, right? So it will just go through each item here, and you know, this is what you're familiar with, you know, as a programmer normally. This is like, this is all happening in runtime, right? Now, since this is a comp time known value, you can add an inline here for. What this will do is it will kind of expand this code. It will kind of unroll the loop, if you're familiar with that. So this will compile into 1, 2, 3, 4, and it will, you know, replace the first one with 1, the second one with 2, and so on. That's all the elements in there. So essentially just kind of expanding this into this code here. So it's kind of like a way to generate code, you could say. One way of generating code in comp time. So yeah, that could be useful sometimes. It's a pretty cool thing. Yeah. Okay, you understand it now. Good. I'm not sure if I explained it goodly there, but yeah. Okay, so now you're asking why zig? Well, I kind of just show you a couple of examples why I like zig. Because you could do things like that. And also it's just better than anything you can put forth. So there you go. All right, it's incredible how many times I get that question. Like people come in here, like not all the time, but I like every other week or something. I get someone going and ask like, why do you zig? I mean, it could also be like it's because it feels like such a troll question sometimes. But I guess it could be like, you know, it could also be a genuine question, so I should probably answer it without, or yeah, I don't know. I just started. Okay. So why zig? I was looking for a low-level programming language when I started my game dev journey, and I saw zig. It looked interesting, so I tried it because it looked like different, and I love like exploring new languages and stuff. So I just tried it and I got hooked. I've been using it for like 2 years now, or more maybe. I don't remember. So yeah, I just think it's an amazing language. Because people use niche unheard of programming language for different reasons. Yeah, I just found it, and you know, I heard people talking about it like online, and tried it, and yeah, it's really good for me anyways. Everyone's taste is different, but yeah. I also need, like, the reason why I was looking for something also, like, I didn't want to go back to C++. Well, what I would say is like this feels more, you have more freedom, it feels like, in this language. It's like you're not stopped by a bunch of random compiler rules. So I don't know, it feels really nice to work in this. Okay. On remove action, you should take, I'm not sure what you actually take here. It's like, wait. On the struct, actually we get a sync only. We don't actually put that in there. So this is the action sync, destruct sync, destruct action sync. And then here we can connect before, connect. Yeah, I guess it's just connect. And the free function. And now we say remove action. There we go. Do you need to be, no, so this doesn't need to be mutable, so you can just say connect here directly, so that's good. No, we don't need to make a thing there. Cool. And what is the type of this function? Params that we provide. That is provided there as well. So, oh, it's registry and entity. Okay. So we get like registry and entity. Never heard of Zig, but now you have. Are you happy with the Zig LSP? I heard they're working hard to improve it. Yeah, I hope they do, because well, it's fine. It's like it, you know, it has had its problems. I mean, I think that Zig is probably particularly hard to make an LSP for, just because of all the comp time stuff, and then the syntax sometimes feels like it can be kind of ambiguous. So it could be hard to make like a performant LSP. I don't know, but I usually have no issues. The times I have issues is when I try to get auto completion for different things, for especially like the implicit declaration access. That is having a lot of problems. And like when you have an enum target and you want to put in dot something, there's no auto completion showing up. So sometimes the auto completion is not working. There are some bugs with the resolution for different types of the signatures for different functions, but that's only in very specific circumstances. The big thing though would be the comp time. Actually, like the comp time, if you have a reasonable, it works with like dynamic arrays, like with simple comp time functions that just takes some type parameters and spits out a type. That it can actually do pretty well. But if you have like logic in the comp time, let's say you have like a type that depends on some kind of comp time variable, if this is like U32 or F32, it doesn't actually know which type this is, even though you say comp time true, it's either U32 or F32. Now it does understand that it's like either or, so that's good, but it doesn't actually compute this, even though it could potentially do it, because it's it's a constant in comp time, so it should be able to understand that this is a U32 and not a F32. So this is the limitation there. Sometimes you have more advanced types that it doesn't really understand, but the compiler eventually will understand, but the LSP does not understand. So sometimes you don't really get help when you want to. Yeah. So yeah, but it helps you keep you on your toes, doing things more manually. All right, so when we remove the action, we also want to remove the implementation beneath. So what I'm going to do is I'm going to say t equals, well, okay, we want to get the action. Actually, this is after. I want to get like before. And before, yeah, it's the same. It's the same actions. Yeah. Or same parameters. So now we're on like before, which is probably good to have. Okay, so now we can actually get the action here to look at the type. Okay, and what we want to do is we want to say, well, I want the actual implementation of action, or we could do action.type. See, I'm not getting even here. Oh, I have to pass in entity as well, right? Okay, now we get it. So okay, my bad. I was thinking like, why is this not working? However, if you do like this, if you say dot here, it doesn't actually understand what type this is, even though if you bind it, it understands what type you should get. And then I can say like action dot, you get all these things, right? But if I don't bind it and I just press dot here, I don't get anything. So that's the LSP. It has these kind of weird quirks with it. Sometimes, there's bugs like that. But yeah, hopefully they will resolve some of these issues soon. Also, I'm not really updating my LSP version unless there's a new Zig version coming out. Because it's kind of like with my Zig version manager that I'm using, not my, but the one that I have installed that someone else made, you get like the LSPs bundled. I was watching Christoph IT just saying talked about it. Some work will be done to it. Okay, yeah, cool. It's really awesome that it exists and that they are working on it because it really helps sometimes. I love having an LSP. So I've kind of learned how to wrestle with it and be productive anyway. So all right. So yeah. So now we have the type. Actually, you are actually not a type. You're a type with... No, you are a type. You are a type. Yes, you are. You are a type. But we can do a switch on the type. And we can do an inline else t. And now we have that. And we can say... action type with pay. We can actually do like action implementation of t, and that is the type that we want to remove. So this will be the implementation. Okay, and then we go get remove implementation from entity. There we go. So now when an action is removed, we also remove the kind of implementation, because the action is kind of like the interface, and then this is the implementation there. All right, now we need to define this, and this is way simpler. So when like the implementation is removed, we also want to remove the action. So essentially, we just want to remove the action. So I'm gonna do remove if exists, so we don't like, if this removal here triggers a remove, the action is already slated to be removed. So there's gonna be like an error there. So I have to do like error remove if exists, action, entity. And there we go. That's all that is doing there. Cool. All right. So that is now, I think that makes the action kind of interface complete, hopefully. And now we are kind of ready to change out this code to use like an action instead. What I'm going to do is I'm just going to remove all this. And direction, we can probably also remove, because I don't think it's really used anywhere except for over here. We're not really using this. I'm just going to remove this. Yeah. All right. And then, yeah, we can remove direction as well. So then we can go to controllable. Actually, right, if we're blocked, okay, if we're moving, then, no, we want to check if we're blocked first. We want to check if we're blocked, yes. Do you use the direction? I think you are. The problem is, this is not where direction should be stored anymore. We should probably just pass in direction instead here. Yeah, let's just pass that in. And the grid. Why do we need this? We don't even need this here, actually. We can just use that, yeah. So let's forget about that. We need direction here. I guess, you know what? I guess we'll store direction here instead. Yeah. We need it anyway, so. Okay, so in this case, direction is left, right, up, and down. Cool. And if we are blocked, so if we're not blocked, then we initiate the thing. Actually, yeah, this is the only place we're actually using that. So yeah, direction is direction. All right. So if we're not blocked, then we initiate the move action. So, so then we're gonna do add CE. Wait. Wait, why does that not exist? What the hell? Oh, I never added that. Ew. All right. This is CE. You know what? Let's take this. Do that. And we'll do that. And I will also do CE mod. It's time this became like officially the way to do this. All right. Okay, and now we're just gonna say mod add CE self CE. Okay. And I mean, if the signature match exactly, what you also can do is you can just say that this is equal to add C, and it will still work as a member function. However, what's kind of weird about this, sometimes when you do this, the signature will be kind of weird. But I think in this case, it's probably gonna work. I don't know. Okay, so like when you autocomplete it, or yeah. Anyway, now over here. So we're gonna add CE. Now we can say action is equal. See, this is what I'm talking about. I don't get autocompletion here. I should get autocompletion. Wait, do I have to do this? No, it's a struct. So it knows the type, you know. And so it should be able to present to me the fields here, but it doesn't do that. But if I do this and then like move or something, now it knows. Okay, yeah, of course, yeah, you were action, right? Yeah. And then we have like move. Yeah, actually, I'll add a convenience function for move here. This gives us a this. Turn move equals init. And then this, I don't think it's gonna understand what this is. So we're gonna go to move. Init needs just a direction. So let's pass in direction here. And that's what we pass in there. There we go. All right, and now over here, we're gonna say move to direction. There we go. Okay, I think we've moved, no pun intended, this functionality now from only the players. Now everything can move using that system. And we're also connecting the player input here into actually adding this move action. So if I start this, we might be able to move around. But I think we're gonna move once and then it's gonna stop. Because we don't have any code for like handling when the action is done. Oh, here we have some issues. Enum field attack. Oh, right. We don't actually have attack, so I'll remove that. Okay, setup. Oh yeah, right. So this one, actually we need to change this to, I think I'm just gonna do connect for that one. We don't really need to know anything else, we just need to use that. There we go. What else is happening here? Value type, blah blah blah, ignored. What? Oh, it's like returning self. Okay. I don't care about that. Okay, here we go. System controllable bull RPG 60 is blocked. Also this, I don't understand why I don't get these errors right now here. Expected 4 arguments found 3. Really? No, we don't need grid. Yeah. Expected. Oh. Wait. Oh, no. You're not a pointer. Okay. Oh, zero size component. Okay, so that means we're adding something that like a type instead of a probably in here. We're adding a type instead of an actual thing. Payload. Oh, because it's void. No, it's not void. And that is definitely not zero. Is it action? Now that has a type, which is an enum. Because the enum, okay, this is kind of funny. So the ECS library does not allow zero-sized components, because then maybe that doesn't really make sense. It's like a runtime thing. So, and I was like, well, this is clearly not zero-sized. But if a struct has all its fields are zero-sized, then the struct itself is also zero-sized. So if I go into type here, it is an enum, but it only has one enum. So it's like then this is automatically zero sized. Zig actually makes this zero sized. So I have to actually add one more. I mean, either I have to add one more, or we could just also add, you know, anything to the action component as well. I could just add like enabled. I usually do this for, that's why you see this every time I have like a component, a new component, I add this enable thing, just because otherwise you can't actually use it with the ECS library. Okay, there we go. So now if I move, nothing happens. Okay, cool. Great. Well, at least it compiles. All right. Cool. So what is happening? It might be that it's not our turn. That might be the reason. But we should, like when we go to gameplay, which we are doing, we are calling advance on turn. That is supposed to then, when it's updating, advance, and then get the next thing in queue, set the active entity, and then set to waiting, and then after that it's not going to do anything. So we should have the player be the next thing, like it should be the active entity, should be the player, because the player should have turn. Did I forget to add turn to the player? No, it has turn. It has turn. Great. Okay, so turn and then active entity has to exist. If we are not equal to the current thing, we continue. If we have an action, we continue. Otherwise, we're going down here. And movement, this should be the same as before. We're setting direction. This is set to true. We add the thing. I mean, what we could do is log here if we actually add the move, adding move here. So yeah, it is actually going down there. Cool. So then it should go in here and it should do that stuff, and then in the end it's gonna call this add function, because that's how this system kind of works. And then this is gonna look, oh, you're a move, so let's add action and this. Great. And then the implementation of move is going to be the type with payload type, which is the actual move component. So it should be that type. And we are also creating it over here. And then we have the move system. Ah, wait. I think I know. It's the classic issue where I have not actually done this here. So I think we could do the move up here. We have to actually call the update function. Classic mistake with ECS. You forget to call the system update function. Okay, so self, there we go. All right, let's see where we are now. Okay, now we get some compiler errors because we haven't called this function yet. Oops. Move system 21, explicit float 32. Wait, why wasn't this an issue before? Oh, because it was a comp time. Okay, so I'll guess this is like F32 will do float from int move speed, and I will use that instead. All right. Oops. Hello, newbie. did you decide which game you're creating? Yeah, I'm creating like a retro style, like RPG thing. I'll show you here in a second. I'm working on like the movement stuff, turn-based movement stuff. Game 307 expected to. Event allocator. All right. No. Component event. Oh, you are not. Wait, the dupe can be an error. Oh, it needs a type. Right. So there you go. And there we go. We can move once, as I predicted. We can move once and then we stop because we don't have a code. So it's like it's the player's turn and then we move. But then we don't have a code. We don't have code for like when the action is over. Now go ahead and advance the time again to the next entity to has its turn be there. So so when the move is done, so we should probably have like a generic like action is action done thing. And when it's done, things will be done. It could be an event. I mean, we already have move done, but we could have like a generic like action done event that will basically, I guess, just advance the turn. Yeah. Okay. So I guess we'll just add action done. Actually, this is move done. Action done is, yeah, it could potentially have like, you know, the type of action or something like that, but I'll just do this for now. So we'll emit two events, move done and action done. Okay, cool. So now that's cool. We have like, you know, that's all we had to do to now be able to store listeners for actions at this event as well. We just had to do that. Unless I forgot something, of course. But I think that's all we have to do. We have to add it here and then here to add like the payload type, and then we're good to go. We can use it. So we add the action done event here, and then oh yeah, I forgot about another thing actually. We don't actually call the setup function. I made a setup function in one of the systems. Well, I think it was controllable. Perhaps, yes. So this is also not happening. We could keep it like that to see what it's supposed to be doing. So because if I add like if action is done, this should be like generic actually, or the turn system should probably have this. Maybe. Yeah, sure, why not? Setup, no. Yep, there we go. We'll do like game on action done, on action done. And then I'll add a function here on action. I'll actually just copy on move done. And this is on action done. And this is action done, which you don't care about. All right. when action is done, we're gonna get the turn singleton. All right, we are going to advance. Once the action is done, we can advance the turn to the next thing. Great. So now that should be all connected there. We just have to remember to call that event every time. But you can see it still doesn't work because we're not calling this setup function. So I'm going to go to setup. And now after all of this crap, we can set up systems. Now after we created the systems, we can now call setup systems, I think. Well, this is really create systems. This is weird. I'm gonna have another function called setup systems here. All right, so we'll get turn setup, and we'll get controllable setup. Now, if you're really keen on using like ComTime stuff, what we can do is we can just say systems that need setup. And this is just a thing. It's gonna be the turn system and the controllable system. All right, and this is a tuple of types, which you actually can, and then we'll do like inline for systems that need setup. We need, and this is going to be the type T, and then we get the system is game get singleton T system.setup game. There should be like everything needed to do that. So there we go. Okay, and it's called, and there's no issue. So, well, there might be here, maybe. What's this? Expected something, found something else. Oh. Oh, right. It actually is more generic. Right, we don't get move down. We actually just get this. All right. Sure. Yeah, I think there is basically it's gonna be difficult to make. It is possible to make the listener type, the hash map type, to be that. You're not gonna get LSP help though, but it is possible to create that type out of the enums. What other thing had it? The turn. Yeah, so it's gonna be the same thing here. All right, let's see now. Oh, well, interesting. You know what? Let's start having like a log of happening. So action done. So I'm gonna say like event. Actually, you know what? Let's actually do this because I want to see if this actually gets called over here. I wanted to add. I'm probably gonna add like a generic thing for that. So that is actually called, so that's good. But I do want to go to the event system whenever we emit something. Or actually, we could also potentially say we have event listeners. Whatever. Where's the emit? Oh yeah, that's actually on game. Have emit event. Should actually always call it from here. So event And this is gonna be like the tag of event. Okay. So now we should like see all the events happening in the logs. So if I start to move, we get move done, action done. You can see there in the logs. Cool. But still doesn't work. So I think I know why actually. So when the action is done, we should also remove it as well. Actually. So we advance the turn. However, before we do that, we have to actually remove the action. There we go. And that is now generic. So the move component will also get removed. Let's bring up the log so I can see the thing. Action done. And now we can continue. Cool. So now we have, I mean, it's only the player moving, but we do have the turn-based system in place now. And things can move around. So we can actually try this now. Let's say we add a little critter or something. So let's go to here. I'm gonna copy this. I'm gonna create a critter type thing. It's gonna be maybe some spaces above us. And it's not gonna be controlled. It's not gonna be a player character. We could, I mean, it could have the same. I was thinking bringing in some other graphics in here. I mean, there's so many graphics here. I was thinking some animal of some kind. We have like unicorns. What is that? Yeah, could take anything. I was thinking like some kind of animal. Are there animals in here? Otherwise we have to kind of make an animal. That's not gonna be great. Yeah, these are all like monsters that can attack and stuff. Do you have any creatures over here? Not sure if there are. What is that? A lamp. Okay. It's incredible with these small, you know, tiles, how much, you know, how the brain can actually interpret. Like, yeah, the person who made this is really talented. Because it's like, everything is like recognizable. If you look long enough, I guess. Sometimes it's, you know, at a distance and quickly glancing is kind of hard to see, but you get it. I mean, most of the stuff you actually like instantly see what it is. So, here we go. Here's some animals. So let's have this thing here. It's a horse or a llama or donkey or something. Moving around. Wait, this is a horse. Okay, well, let's take this one. So this one is at 66, 183. Wait, what the hell is this? Oh, is that why? Oh, that's why we get like a white rectangle. Okay, I guess we'll do like, well, I guess we'll do like an animation here for this. Let's do a, I don't really know what it is. A llama. Is it 2 L's in llama? I think so, right? It seems weird, but I guess it is. So this one is, what was it? 66, 183. Winamp llama. Old school stuff. Man, I missed I had like Winamp visualizer where it had all these weird things going on while you were listening to music. I kind of missed that stuff. Only the old timer will understand. Yes. I don't know how many people are using Winamp nowadays. Because you usually don't have like music on your computer. Because you're using Spotify or something. Next project, port Winamp in Zig. Yeah. Alright, so this is Llama. And it's gonna have a turn. We can also make it like, let's say speed is half. So it's gonna move like half as fast as we are. Okay. Now, well, the only thing, the issue now is like, we don't have a way to kind of tell the llama, hey, you're supposed to move in this direction. There's nothing like advancing the turn for this critter here. So, but let's create it anyway. Create the critter, please. And it's gonna show up. I have not downloaded any music. Okay, Blue. So there we go. There's the llama. And I can't actually move now because I guess it's the llama's turn. So it's not doing anything. I mean, I guess it should be the player's turn. Is it because it's like reverse order? So you have to create the player last to be able to like have your turn first. Also, everyone has like their turn first. Maybe the player... No, wait. What's happening now? That's... Well, actually... You know what? Let's check out... Are we updating next action at? Maybe we are not. So we have the entity. Yeah, okay. So we should also update. I forgot thing here. I have to get the turn. If it exists, that is. And I need to set this to be plus equal the cooldown. There we go. Because otherwise, nothing is gonna like move. Yeah, everything just has the thing. Yeah. There we go. Now I can move on, and now time is advancing. I can't move anymore, so it's the llama's turn. But the llama is not doing anything. So, yeah. You know what? Also, turn is like, let's say next action at is actually not 0. Let's set this to be like the cooldown. Which is a conundrum because we can't use it with default. Let's just remove default. Then, actually, let's make default a function instead, I guess. No, let's just do init1. Okay, and then next action at equals. No. Hang on. It's just gonna be... We're just gonna call the function. Init1. Alright. And then we don't need to do that. And then next action at we just set it to cooldown. And then we return to, so there we go. So now we're calculating. So at first it's like, well, we have to advance time to get to the cooldown. So I think now I should get 2 turns before the donkey or whatever it is. Yeah, there we go. Because first we go to time 1, I get a turn in. Then it goes to time 2, I get the next turn because I'm first in line. Okay. Yeah. So. Right. So now. Yeah, so, okay. So how do we make the donkey move? We need some kind of AI system for the donkey. So, or llama, I guess it's llama. It's just more fun to say donkey. So we need like an AI system for things. Now, usually what I do with this is I usually have a state machine system. And I'm surprised I haven't actually put the state machine system in my template project yet. Maybe it's time to do that. But for now, I will actually go in and copy over some other stuff. Now, where do we have the state machine system? I think we have one in the Raylib game jam. We have, for example, we have state machine system here. I don't remember if this was like my favorite one or if it, let's see, it actually is a pretty simple one. Yeah, this one is not really that great. Where did I have the things? Let's see. Well, I mean, I guess I have one in Kottefolket, I guess. Yeah, I guess I have one here. And we have iterators, generic iterators. I should probably bring that in as well. That's pretty cool, actually. Okay, so we have state machine somewhere. It's this one. This one is like fully fledged almost here, I feel like. So I feel like we could use this one, yeah. It has a whole bunch of stuff. It even has like, you can have multiple state machines on one entity. So yeah, let's bring this in, I guess. And I'm gonna create a system called state machine. And I'm just gonna paste this in here. And we don't really have, yeah, this is a little bit different because now I usually have something. I just take game. We don't really have L for lib either. Okay, what kind of issues do we have? So we have like entity ID. We don't have that either. That's right. But that's just for, that is just for debug log. So I think I will remove this actually. Yeah. Goodbye. Okay, we have a state function, UUIDs. UUIDs, we're using that for something, I guess. But that, okay. Because we have a map of things. I think we can just use, instead of UUID, we can actually use index. Yeah, we could just use like array hash map with a usize. U size It's an auto array hash map actually. Wait, why does that not exist? Auto array or auto array hash map unmanaged. Okay, sure. So then the handles with the U sizes instead. State function, we need to have URI U size. Probably don't need all this crap though. We need a context as well, that's right. I'll probably put this on game instead then. Alright, so that was that. We have utils. There's also the wait. Where is? Oh, I see. It's just here. So we don't even need to do that. Function, wait. Function, UUID. It's alive. Should I just get? I'm just gonna get rid of these timed functions. I don't think they're important. Yeah, I'll just remove this thing here. It was just a way to kind of add a thing that should happen later. But let's just remove that. Let's remove this clear time function. Don't need to do this. All right, that was it for that, I guess. Wait, was that really it? There was like state function. Oh, I see. So that was removed there. Cool. Now, so this system here. Wait, what is this filter? I've forgotten about this. Filter all. Filter iterator. Machine state filter. Oh, I see. It gives us like the different state machine if you have multiple ones, right? And you can enable and disable them individually, right? Right, so you would use this function to actually create a state machine onto an entity. Well, actually, no, this would already have. This would already be a state machine. I'm pretty sure we had that function somewhere. Oh yeah, I was also experimenting here with the language stuff, and actually I redid the thing just to be able to do the identifier. I'm not sure if you follow this or not, but I did. So I actually managed to make this work, and I've learned more about making comp time stuff. So everything is like compiled in comp time. So basically, while you're compiling Zig, it's also compiling the actual program. and then so we compile it in comp time. It's compiled, and then we get a payload out, which is like an evaluate, is something that we can evaluate, and then we call evaluate to get the actual output, like in runtime. So that's pretty cool. Anyway, back to this. What did I want to do? Right, I want to check out how we actually registered the things. Maybe it was in here, register station, yes. So this one actually is things we would like to have. I'm just gonna do this one because we don't really need more than this, I don't think. And if we do, we can just bring in another one. All right, so now I can go to, for example, game, and we can add this function here. Now the context actually can be entity context. And then we have initial state, which is a state function. The state function, what I'm going to do is I'm going to actually import this here. So state machine, I'm going to call this sm mod.state function. This is going to be import. Actually, it should be like systems state machine. Wait, so then we already have it. So then I can just use state machine state function. Wait. Where is this? Oh, it's here, but it's on the file, I see. Okay, so then we actually do need this. Systems. It's not like laid out the same way as I did in this, like in the same patterns as I'm using in this project. So it's a little bit different, but whatever. All right, so we have the state function. We can use that now here. The state machine component, we also need, I believe that should also be like on the same thing. So yeah, state machine component. I think it's this one. This is the component right here. Okay, let's just go to component. Actually, I'm gonna create a component so we get this properly here. State machine. All right, and then I'll just move this over here. And we need this state machine internal. Is over here. Let's copy that, bring that in here. State function, we can actually state function equals game.state function. It's easier to alias it like that. What else do we have? State machine key. All right, so the key, what else do we have? Filter, default key. Okay, are you used anywhere else here? You are in the system, right? So we could store that here, I guess. Let's do this, and then we have state machine key. It's gonna be that. Then we have default key and filter. Actually, is default key used? Yes, it is. Okay. And then we have the key filter. All right. Whoa. Oh, right. And then here we could do like state machine equals game C state machine. Could also do a replace, but whatever. Oh, we need internal as well. Okay, you know what? Let's just do like internal equals state machine internal. And then over here, we're gonna replace all state machine internal with state machine dot internal. There we go. Why is that white? Internal. There we go. All right. Cool. Okay, so we brought in state machine now. And what we could do is to make this into our system, how we usually do it. And this, instead of this being just adding the state machine, we actually need this to be like a state machine in it, because we need this to be a special thing. And we don't really need that. We don't need post. We can use it here. So state machine in it. Now I think the only thing we need is like the function. So this would be like initial state. And this is like state function. I believe this is the way to do it, probably. You can. What's interesting is like Zig does allow you to pass, like to have a function type like this. Like you can have a function type like this. That's perfectly acceptable. But you can also pass in like a constant pointer to a function like this. I don't really know if there's a difference. I don't think there's a difference because, you know, this kind of implicitly means, you know, the pointer to the function, as far as I understand. So I don't know. I'm just talking out of my ass. But anyway, you know, because a function essentially it just exists, you know, at one place. But although what is interesting is like the comp time stuff could potentially generate multiple versions of the same function. So although then you would have to pass comp time parameters. So that is also interesting. So actually then a pointer to a function might actually lead to multiple addresses. Ah, I never actually thought about that. But anyway, there shouldn't be any a difference though between those two. I don't feel like. It's just it's more. I guess it's like, yeah, it's a pointer, so it's more explicit now. I guess, I don't know. Maybe there's another difference. So anyway, so state machine in it. So this will be like initial state is a constant state function, constant pointer to a state function, and we will initial state. No. We will set that there, and then when we add, what we will do is we will say game register. Wait, game. Right, we need like self game context, entity context. No, maybe we'll self allocator. Initial state is the state function. We get this register state machine get or add state machine. Oh, right. So in this version, I added like a default value. Yeah. No, I didn't. No, in this version. No, in the old version. Right. So get or add. I guess like if it should not exist, it should really not exist. So I'm just gonna say add. This, I think this just replaces if it exists. Yeah. Which can be bad if we have like, if you have like allocated stuff on the thing that disappears, but anyway, context as state machine in it. It's a state machine in it, but now we don't. Now we do that instead. And we don't get you. Actually, we have to get you. Wait, what the hell? Oh, I see. Right, state machine. Now I actually do have C because we're in game. In the namespace where it exists. There we go. And now we can call register machine on the context. It could also, I could also move this to, actually, yeah. I'll just move this actually to the entity context. Yeah. There we go. Because then we don't need this. We can just say self and there we go. And then we don't need to call do that. Right, and then it's just going to be self initial state. Okay, so right, so now we can now we can add the state machine using our new nice component enum system. So let's go back to the thing. Okay, so basically now we have a new system, which is a state machine system, where you can kind of define a state machine that is going to be attached to an entity that is going to be able to do all kinds of stuff, essentially, on that entity. And it's going to be run by the state machine system. So all we need to do now is I need to go back. Well, I need to go to the critter. Well, actually, first I need to go to update. Well, first, it doesn't matter which. And then do we do state machine here or here? When is it good to do a state machine update? Is the question. Maybe before the turn? Not sure when it's a good time. I guess it doesn't actually matter that much because it matters more in a game where the frames are very important to happen very quickly. Like, well, it's not gonna lag, but it's more like if things get delayed by a frame, it might, you know, feel less, you know, in a physics-based game or something like that. But here, I don't think it really matters that much. We can even do it up here. Let's just do it here, I guess. So this would be the state machine system. There we go. Wait. No, this is the component. System state machine. Where is the actual? This is a context. This is like the thing you use. I might change this because I kind of like replaced this for another context. We'll see how we can like merge these concepts. We have all this filter stuff and the frame functions. Here is the system. So this is the actual system. So I'm gonna go to systems, and we have to do that now. Interestingly, you could have accessed state machine, even though it wasn't actually public here. Interesting. Okay, well, anyway, now it should be, wait. Well, there's an update function, only it doesn't have self. Okay, I see. So let's just, actually, yeah, we don't actually even need to instantiate this, but I'm gonna do it anyway because that's the pattern I'm using. So I'll just have like init, and we don't, well, okay, init singletons. This is kind of like its own thing. Sure. You know what? This is more like a setup. Yeah. That's a setup. Game, add singleton. There we go. And so that is going to be called from setup. Systems that need setup. So now we can just add, look at this, it already pays off state machine. What? Okay, we can actually do one better here, or better, it depends on how you look at it. But what we can do is we can actually go and basically, we can go to, so all the systems exists in this S thing here, which we just import systems. This has all the systems that we have, right? So technically, S is also a struct, and these are declarations on this struct. So we can actually in ConTime iterate through all these systems and automatically, now this is like, you know, it's kind of, it's like a little double-edged sword, but if you know what the pattern is and you have control over it, then it can be really nice. So it's just that you have to remember how it works. But what you can do is you can do an inline for of all of the systems. So what we can do to get the declarations, you can say meta declarations. We get a declaration, and this declaration has just a name. But with the name, you can actually get the system type with a field built in of game S and declaration name. Okay, so now we have the system. This is a type, and because it's one of the, it's going to be one of these declarations. So we're iterating through all of these, and we get out, this will get out the actual system type here. And now we can say if we have a declaration on system that is called setup. So basically, if we have this function, you can also say like a more like has method on system called setup. So this will actually check if there's a function called system, or I mean called setup on the type. It also checks if it's actually a method, which means the first parameter has to match the type. I think has function, or maybe it doesn't actually do that. Huh? Anyway, we can use this anyway to check if the type has the function anyway. So, and then when it has the function, what we can do then is we can say, well, let's fetch the thing. So let's fetch the system and call setup. And since it's gonna be every function should be the same, like follow the same pattern. Otherwise, there's gonna be a compiler error here. But now we don't actually need to have a type, or I mean a pointer, or a tuple of types here to determine, manually say which ones we need to set up. Now we just loop through every system. We check, does it have a setup function? Okay, call it now. So there we go. Now we don't have to worry about that. Hello, it is a hobby. What's up? How's the game going on so far? It's going, I mean, it's going good. I'm kind of doing some fancy programming stuff, which I also think is fun. It's like part of the fun here. But now we have this setup function. I'm gonna show you here in a second here. So we have the state machine. I'm just gonna see if we have any compiler errors, which we probably should have a bunch. Default key is not marked public. Okay, let's make you public. Setup 53, unable to resolve compile, right. So I'm not sure if this is the place to put comp time. No, it's not. Wait, what is the what is this? This doesn't understand that this is comp time. I think if you put comp time there, okay, it works now. Good. It's weird. Sometimes you have to put comp time in order for Zig to actually treat it as a comp time. I would think like if something is comp time known, why not just add comp time automatically? Like it doesn't really make sense to me. I mean, there might be reasons for it that I don't understand, but okay. So setup 58. No field members. Yeah, so you get this because I don't add comp time here. If I add comp time, now it will actually not consider this branch when this is false. Otherwise, if it's not comp time, it will actually go in. Well, before I speak too much, I'm gonna recompile here. Yeah, okay, so we still get this issue here. But yeah, sometimes that is the case. Like even if you put a if and you don't say comp time and you have but you have a comp time known variable in there to determine if it's true or false, it doesn't actually apply comp time kind of structure or logic when compiling to it. But if you put the comp time, and it turns out to be false, it will actually skip compiling the inner part. But it doesn't do that if you don't put comp time, even if it's a comp time known variable. So yeah, it's a little bit confusing sometimes there. Okay, so no stuff main function setup in this thing. Right. Did I forget to put... oh, yeah. It also needs... So this is part of the interface. You have to have a self. There we go, even if you're not using it. So there we go. But it's also interesting. If we now, for example, I remove comp time, will we get an error here? Yes. No. Yes. Look at this. No, wait. This is... Okay. I'm just kidding. I'm just lying here to you. All right. So the update function. So now we get this here, and we need like a bunch of stuff. So I think I'm gonna update maybe this here. This is like the old pattern in my previous projects here. So the new pattern is just to have game, and that gives you all you need. Instead of having a view like this, we have an iterator that we determine directly from here. And we can just put state machine in there. All right, so all the state machines, we are going to iterate, get a context, and this is the state machine context, which I'm also contemplating whether to merge with like our current kind of entity context, because they do overlap a lot in what they are doing. But anyway, let's keep it like this for now. We have an iterator, right? So view get, so this tries to get the actual state machine here. So let's just get the state machine like this. This will be context get state machine, and we'll replace you with state machine there. And you just iterate through. Why does this need to be a pointer though? I mean, I guess it's so we don't copy it, I guess, that way. But it's only used here, so it's because it's an unstable pointer, so I wouldn't, return it or anything. But it's only used in here, so there we go. Okay, so we're iterating through that, and we're calling state. Right, this is the update function, yes. And right, so you are ready. So I'm just gonna pass this in here. Also, we don't have entity. I'm gonna do that. T is like time, so it's like, it's kind of weird how I did it back in the day. You know what? I'll just change it right now, perhaps. Either I'm gonna merge, like either I'm gonna take out a bunch of stuff from here and put it on my entity context. But this is also a lot of stuff here is only for state machines. So maybe not. But we also have like this, like get, like all of these basically exist on the entity context instead. So maybe instead of having these here, maybe we'll do something else. Like adding the entity context as a field on this one. So if I remove all this, also we have like IO and allocator here. That's kind of interesting. We don't really need those. So I'm just gonna remove that. Random, we don't need that either. Timer is, this is also interesting because I need to update this. I'm gonna add game as a thing here instead of registry, because that exists on the thing. I'm also gonna add, actually, you know what? I'm just gonna add, like, instead of entity, it's gonna be entity context. And that basically has all we need. So this is just a wrapper around entity. And right, so we have to change a whole bunch of stuff, but it's gonna be good. It's gonna be good. So, man, there's so much stuff in here. And we also have valid. I'm gonna remove that as well, because that's on the other thing. All right, create actually creates a new thing. It's like a convenience thing. I'll probably remove this. Maybe. Because we already have this on like game. So as long as we can get to game, we don't really need this. So I'm gonna remove that. For entity. All right, this creates a new context for another entity. That's right. And also over here, we can essentially, like if we have game, now let's just do this. Yeah, let's just do that. And well, for entity, this is like, we rarely nowadays, like in older projects, I would use this all the time. But in nowadays, I only use like this type here for all my entity stuff. So we probably just do this. But the reason for this was just a convenience, because it was such a pain in the ass to copy all the things every time. So I don't think we actually need this now. I'm just gonna remove that. And all of these functions now, like context get, we could just say context get entity get now. So that's gonna be the same thing, really. All right. And then, right, so now here, we can just do init game and wait, no, it's just gonna be context. We already have the context, right? There we go. So we create the thing, we pass it in here. Is this right? This actually just needs to be, I mean, I could just do this then. We don't need, yeah. Okay. Simplify is good. Okay, you're an iterator over state machines. So I'm gonna call you state machine iterator. So this is like, so what this is like, it's like a state machine container actually. It's like the events container. It has it can have multiple state machines. Usually we only have one on an entity. And then here we're just looping through all the state machines, and we call the state function on the thing. Okay. End functions. Do we even want to have these? I'm not sure. State machine end of things functions. I don't know. It's like if you can add an end of frame function, that's something that gets ran at the end of the frame, which is good for some things, I think. But I think I will just remove this. If we need it, I'll bring it back, but I would rather remove things from this that we don't actually need, because it could be replaced with other stuff. So all of this, actually, I'm just gonna remove all of this crap here. And then we actually don't need this setup function. And what's also nice here is like all we have to do to not call this function anymore is just remove it. So now it's just it doesn't exist, so it's not gonna get called. So that's actually pretty nice. And now let's get rid of this crap here, and then we don't need to actually do anything here. And the only reason to have a deinit here is just to deinitialize that thing. So let's actually remove that as well. Cool. All right. So, okay. So this was actually pretty simple now. Wait, did I not? Okay, let me check this again, because I might have misunderstood something here. If I go to state machine here. Okay, so we actually did have pre and post. I thought that, well, maybe not post, actually. I don't see post here. Yeah, we don't have post. Okay, well, because I was thinking like, that was like a very tiny version of the state machine system. But yeah, now we basically brought in the big guns, but I scaled it down. So, okay. Anyway, this is now getting called. We're updating the state machine. It's going to go through all the state machines, update them as well. We have the state machine component. We have state machine context. We are now, I think, ready to kind of create these state machines. So I'm just, yeah, and then in here is basically everything needed to kind of have a state machine as data here. And here we have the post and stuff like that. So yeah, cool. Now let's go back to demo. The thing now is like, in order to have a state machine, we kind of need to create the state machine. So I'm gonna add the state machine here. It's gonna be init, and the initial state, we need a state machine kind of function here. So this will be like critter state machine dot initial, which doesn't exist. So I'm just gonna create it here because it's gonna be super simple. Wait, critter state machine. Now the state machines in my version here is gonna be it's just a struct. Well, technically it's just functions essentially, but I usually store them together in a struct. So this struct has all the state machine functions on it. The way it works is that you start out with an initial state, which is, so the state is actually just a function. So you start out with an initial function here, which takes a state, actually this state machine context. Yeah, we should actually alias that on game. Let's do state machine context. It's gonna be that. That is public. Very good. All right. And then return void. Okay, so the way this works is, this is the state function initially, which means that this is like the update function for the entity. So it's just going to get called every frame. And what you can do with this context is you can set the state to another state. So you can determine, okay, when should we change the state? Let's set the state to some other state. Now this new state can be a function, but it can also be like a group of up to 3 functions, which is like the pre function and the update function and the post function. And so, yeah, I can show you here. So basically the initial function, well, let's start with this simple example here, actually, before we do that. So what you can do is you can say, now we have like the entity here. So we can get, for example, actually, I want to have a convenience function to say, like, is it my turn yet? So are we supposed to do something, actually? So the way I would do that now is like, I would try to get the turn singleton, and then we'll check if the active entity exists. Now I'm gonna put this in a convenience function here, but active entity is active entity, or else if we don't have an active entity, we don't need to do anything. Okay. And then if we do have an active entity and the active entity is equal to our own entity, then we want to set the state, or then we want to actually, no, not set the state, we want to actually do something. So what we want to do is we essentially want to say, oh yeah, also another thing that we need to check, if we have an action, then we're currently performing an action, so we don't do anything either. Okay, so then over here, all right, Penguin. Actually, let's just do this. If we don't equal, then we return. Okay, and after all of these checks, now it's our turn, and we're not currently performing an action, so that means that it's our turn to kind of determine an action based on everything in the game. But for this critter, I'm just gonna like randomly move in like a direction, I guess. So let's do game, well, we have like entity game. So there is like random, there's like enum value and direction. So we could get a direction, like a random direction like this. And then we can say, add a action is going to be move and direction. Okay. And then we're basically done. Next frame, we're going to have an action that we're going to be making an action. So we won't actually do anything. And I think we're done, actually. I mean, this is the whole state function. Now, for a more complex state, we could have things like, let's say it's like, you know, let's say the player is approaching. So the player is like close enough to the critter, and the critter can enter fleeing state. So now it's in fleeing state, so it has to kind of flee from the player or something like that. But for now, let's just test if this actually works here or not. We have some issues here. Demo 33. Are you not correct? Expected constant function t found. Oh, so this is not a pointer, right? Okay, there we go. Okay, so if I move once, and now it's my turn again, so I move, and the horse, or whatever it is, the llama moves now as well. Nice, in a random direction. So cool. I wonder if it will move. Yeah. Okay, so the action move does not actually check for blocking, so it can move wherever the hell it wants. Which is kind of good, actually, because then it would allow like flying units to be able to move through. It's like swimming in the water here. And I can't actually move out there. So cool. And while it's moving, I can't actually do stuff either. So yeah, awesome. We have the kind of the basic, framework kind of in place for turn-based movement now, which is really cool. Okay. Now, great. All right. The question is now, I was thinking about this before. Like, if let's say we add a whole bunch of these. So we add like a bunch of critters. I'm gonna change you to receive a position. And instead of us doing all this crap, we're gonna do this. All right, that is the critter there. Now that should be the same thing. Yeah. I'm gonna add a bunch of these. 4, 5, 6. No. Let's just add 4. Let's add this at 10. Let's add. I'm gonna surround the player here. All right. Now we should have four of these. And if I do 2 movements, yeah, they all do in their turn order there. I can't like move into them because there's nothing like blocking there. Because what I was thinking, like, they all do their turns in turn, okay? Even though they could potentially. What I was thinking is that if you have like multiple enemies, like supposed to be doing stuff on the same turn, maybe we could have them all determine their. I mean, okay, what we could do is we could simulate what we could still go through in order, so that the simulation will have them move in order. So my goal is to try to have them move at the same time, but I still want them to kind of calculate their movement as if they moved in order, if you see what I mean. So that you don't get things like, let's say we have a rule where enemies can't like occupy the same space, more than one enemy or entity. Then they have to know if it's gonna be blocked or not. So everything has to happen in a sequence in turn. But if we wanna make it so that all move at the same time, we have to first kind of simulate or calculate in turn everything, and then kind of replay what happened, essentially, is what I'm thinking. So, and also, what if, like, okay, I wonder if it could go one step further also, like, even if you have enemies that are kind of slower, or, enemies that are even slower, so they would do things in a different turn as well, then maybe those will also like move at the same time, unless it we can have maybe like an algorithm that checks like I don't know, that checks like if there's gonna be a conflict of movement or conflict of things. And if there's a conflict, then we have to kind of play the animation in order. While if there's not a conflict, we can just play everything at the same time. So, okay, that's gonna require some changes. I think I'll start with the first one. Like if you have monsters that are like starting at the same, like we will play those animations at the same time. Potentially though, what you could do is just record everything, and even like because they can potentially have like multiple actions in between. Or well, let's say like this: you have one enemy that is twice as fast as another enemy, so you can show that by having the one that's twice as fast move twice as fast in the animation as well. Like in the case where you have multiple enemies moving at the same time. I don't know. Let's just start with a basic thing there. Like if they all move at the same time, or if they all do their action at the same time, we allow them to do that at the same time. Okay, I'm gonna do a couple of changes to the turn system. I also realize I need to do another thing as well. So find next entity in queue. So basically here, I think that then active entity is actually gonna be a list then. Yeah. I mean, actually, you know what? It could just be component based. Like we could just create a component that is like active turn active or something. And this just says that it's this thing's turn now. You can do something. Instead of having this active entity thing. Yeah. So that we actually don't need to do that. And so I guess if we were to do this here, we can just say add. Actually, if we have it, we say add turn active. Okay. And then when action is done, we advance the turn. Advancing the turn will set the mode to advance. Oh, there's no like resetting the active thing. I guess when the action is done, we can also remove. Actually, you know what? We could remove the active done whenever we do an action, actually. So whenever we actually like add an action, we also want to remove the active turn. It doesn't make sense to have that, because what that does is essentially now, instead of checking all of these things, yeah, we don't need to fetch turn, we don't need to check active entity, we don't need to check if we have an action. What we do need to do is check if we have a turn active. If we don't have a turn active, it's not our turn to decide, we don't do anything. Otherwise, we actually do something there. Okay, and we add this move action. Now, great. I also need to change controllable, because we're kind of doing the same thing here. Where is that? Right, yeah. So we're doing the same thing here. So instead of doing all this, we just check, do we have turn active? If we don't have turn active, we continue. Yes. All right. I'm also gonna return remove that, because we're not actually using this here. Oh, that's not actually used at all. Cool. All right. Okay, so what now? Now, are we back to where we were, or am I missing something? So basically, this gets checked. If we don't have active turn, right? If we don't have active turn, we don't do anything. Otherwise, we do a move action in a random direction. Okay. Then, what was I thinking about? I don't remember. Right. Actually, I should use this. All right. Okay. At some point, I'll probably just remove the original way to use add and then use this system instead only for adding things, because it's more flexible. And probably gonna be the standard way to do things. Are you not gonna use GPU this time? GPU. I mean, Raylib is using GPU. Okay, so everything still works. Cool. Actually, I should enable. I do have the shader. I have a CRT shader that I can enable. So there you go. Now we're using the GPU a little bit more. Yeah. Oh yeah, and enter location actually works as well. Oh, okay. So, okay, so the critters actually don't get removed, so they are still in here. That's funny. Okay. Yeah, because yeah, so, okay, well, whatever, it doesn't matter. I was just testing, like, yeah, going into the locations actually works now because of the event system that we have. Cool. All right, so how do we get them to kind of move at the same time? What can we do there? Do you have any ideas, Blue? Could you all, yeah. So what's interesting here is like you ask, you know, gonna use CPU when I'm making like this very retro pixel art game. It's kind of funny, but I was thinking like, okay, what kind of shaders or what kind of shaders or whatever could we use? And I guess CRT would be like an obvious choice because it's like a retro pixel art thing. Even, you know, super retro. I don't know what other shaders we could use. Maybe, yeah. If you have any suggestions there, that would be cool. I mean, I guess we could have this kind of retro style, but then incorporate some maybe effects that are like more modern in a way. I don't know. We'll see. It would be cool to kind of polish, like add some nice stuff like that. I don't mind, you know, enhancing. It doesn't have to follow, like I don't have to emulate, you know, you know, Odyssey or whatever. Spectrum, ZX Spectrum or whatever, Double Vision, ColecoVision. Okay. How do we make them do stuff at the same time? Good question. Good question. So they should actually all have. No. Yeah. It's just, I think we just need to make this return a list instead. Or we could have an iterator potentially instead. So I'm just gonna do like Q iterator. We need next. It's gonna be an optional this. And it's gonna be like, the thing is, an iterator is kind of weird because we kind of need to store, we kind of need to iterate through everything anyway and store like a list of things anyway. Okay. Maybe an iterator is a bad idea here. Let's just make a list. So I guess we'll have like result is an array list of these. Well, yeah, it's an array list of. We could have, maybe we'll have timestamps. Yeah. Let's just have timestamps here as the context and time. Okay, and since now we're having a list, we don't need to make this optional, because if we don't find anything, it's just going to be an empty list. So this is going to be empty. And we'll go through. Now the thing is here. Actually, you know what? What if we add all the... We add them into a list. We add everything into the list. And then sort. Yeah, okay. append the item, which is entity is context, time is turn next action at catch unreachable, and then I'll just wait with this one. So here we add everything. We add everything. Now we have this list. Then we sort it. So there's no sorting function on the thing, but we can use sort here, which has like two versions. You can have a context, which I believe would be nice to have. Actually, wait, what is this? Oh, so we just called sort. Now the type that we're sorting is this thing here. Which I've yet to name. Essentially, it's like Q entry, maybe. And you're gonna be a list of Q entry. And you are, oops, Q entry instead. And you are Q entry. We're sorting Q entries. We have items is result items. The context is I guess, wait, do we actually need a context? I don't know that we do. Well, let's just do game. And then we have a less than function that takes the context and then two of the entries and returns a bool. So this is like a sort function Q entry. So sort function Q entry takes game, it takes left hand side, which is a Q entry, and then right hand side, and returns a bool. And we simply return if the time is less than right hand side. Oh, also, I realized something. If the player, I was thinking like if the player is part of this list, maybe the player is going to have priority. Maybe, or maybe not. But yeah, now we don't need to do this. Okay, so we've sorted the items according to which one has the starts first. And we could just return the entire list. The question is, do we return up to the player? Or do we just return the ones that has the current, like the current time? So we essentially want to find, so let's, if we loop through the items and we're checking So the least, so basically, well, first I want to check, do we have any items in here? If the length is 0, we just return this. Okay, so down here we know that we have at least one item, so which we essentially always should have. But let's do, if we have at least one item, we're gonna say that the minimum amount of time is gonna be the first item, because they are sorted now. So that's going to be the first item. I believe it's ascending as well. Does it say that? Default ordering. Wait. Sorts in place using a stable algorithm, maintains relative order of equal elements, average time, complexity. It doesn't actually say if it's ascending or not. Okay, so what do you do? Sorts in ascending order. Okay, thank you. So it's ascending, which is perfect because that's what we want. Min time is the first item's time. And then essentially what we want to do is we want to compare, like if item time is more than min time, then we want to cut off at that point, I think. So let's do like cut off index is gonna be if this happens, we want to break I. So that is the cutoff index. If we don't find a cutoff index, I think that's just no, that's not gonna be unreachable, is it? I don't know. It's just gonna be the length of the items, I guess. Okay. And then the actual like queue result is gonna be item 0 to cutoff index, and that's what we should return. However, we need to like do two own slice here as well. Right. Two on slice gets us a slice. Oh yeah, then we don't have items anymore. There we go. So we'll return the queue. Oh, but how do we delete it? Can we just kill off? I mean, I guess potentially we could just return the entire list. It will handle that for us. Yeah, we could just, I believe this should be copyable. I'll just return this. Return results. No, wait. Yeah. Because then we can say, wait, can't we just change the length? Resize. Yeah, it just sets the length on the slice. Won't that mess with the allocation? Maybe the allocation is stored in another thing. But where is that? Capacity, items. Oh, maybe like deinit actually like casts it, or like allocated slice should, I'm gonna guess it takes the items, it makes a new slice that has the items pointer, but the length of the capacity. Yes. Oh, it actually does it like that. Interesting. Okay, well, anyway, let's resize with the allocator. View length should be cutoff index and capture reachable. Yes, because it takes an allocator, so it should be an allocator error. Yes. And now we don't need to do this. We can just return the result, and that's great. Cool. Find next. I'll just rename this to find next in queue. Right, you are not used anymore. Great. You are not used either. Cool. Okay. So now, but you are called here, and you don't have a thing called next. So, so actually advance. Now we actually have, instead of doing this, we have to loop through next.items, and here we actually get an entry, and entry.entity is the context. And we get turn, and we do that. Okay, I guess, is that it? Oh. Systems, turn 34, no field name time. Oh, yeah. So, well, now we know that every of these has like the time is gonna be the same. So we can just set the time to entry.time. It's probably, and even if they're not the same, it's still gonna be good because, yeah, we're gonna get like the correct one anyway, because the latest one should have the largest amount of time anyway, since they're sorted. Okay, we've got 63. Items length 0, return, and all right. Actually, we could just return empty then. Yeah, cool. Are we through? Will it work? Okay. Well, except I can only move once now, but it does work. But I can only move once. Also, why am I off? Unaligned. It's like I can do things in between the things. Yeah. So I think it's because of this here. We advance. Every time one action is done, we advance. That should not be the case. Well, it might be the case. We have to check if all actions are done. So we remove the action. After that, we're gonna, I can do like count or size or, oh wait, count, no. Game like count, size, no. There's like data of action length. If that is 0, then we'll do this. So now it's like, okay, if nothing has any actions, then if there are no more actions being performed, then we go to the next turn. Have a little bit of struggle here with the language, but they still kind of move. Okay, now I can't get a turn in, I don't think anyway. in between. But they still like move. Like even though it's my turn, I should be able to move twice in between. I'm not sure why that's happening. So let's check this out. So I think I have to go here soon, but I think I'll try to sort this issue out, and then we'll call it here. A really productive session this time. So we add everything. Actually, you know what? Here we could just dupe. The turn thing instead. Although then we don't have the actual time. No, we actually do have the time. Although we kind of weren't, but then we're gonna miss some other stuff. No, that's not. Okay, anyway. That is sorted. We get the min time. We're gonna check as soon as we find an item larger than min time we break. So first, the player speed is 1, the other one is half. The player starts at turn 1, because we have to wait for 1 cooldown first. So the player has also, like, if I start, okay, they don't move at first. So it's the player's turn first. Player has time 1. I mean, I could just log this out. We could just do some. Welcome back, Penguin. We could just do some. I think you said it like 20 minutes ago. When action is done, where do we advance the time? That is happening here. So entity active at, and we don't actually have a way to kind of show which entity it is. We could show, I guess we could show the index. Actually. No, wait, what? Oh. Index, there we go. Looks a bit weird, but whatever. And then entity active at is time, enter time. Okay. So we have a little bit of way, a tiny way to see if, like, what's going on maybe. So entity 4 active at 1. So that should be the player. Okay. So then it's like move down, action down, entity 4 active at 2, but then everyone else is also active. And the player is like active as well. And then everything else, and then active at 3. So actually, it seems like it's moving past the player because there's no actions left because we haven't actually started our turn. Okay, so we can solve this, I believe, by just adding another check here. We could check if their actions is actions left. It's gonna be this. Come on. And we also have like is so we can have actions, and then we can have things that are currently trying to, or like if the player wants to do the action. So it's like, but I think I want to change how that works though. So is active entities left. So that's gonna be turn active here. Okay. So is there, if there are actions left, then we return. If there are active entities left, then we return. Otherwise, we will advance the turn. Makes sense? How will this play out, though, is the question. Nothing happens. Is action... Oh, wait. Is more than 0. It's more than 0. There we go. All right. Okay. So now there's a difference now, because we see that we're at 1 first, and then we move. And then there's like a whole bunch, everyone's as a 2, and they do their thing, even though I'm still deciding what to do here. But then it didn't actually go through to the next thing. So if I move now, they don't move. Yes. So now it kind of works. Cool. All right. It kind of works, because I don't really want to do my turn at the same time as they are doing their turn. Like, the first time I move, it's actually my turn. I'm like deciding what to do at the same time as they are kind of already moving, which is kind of weird. So I think what I'm going to do is, like, if we encounter the player during, like, the player should have priority. So when we're looking for the cutoff index, not only do we look for time, we also want to kind of check first if the player is part of this group here. Actually here, yeah. So if the player is part of this group, then we only consider the player. So like so then the player gets like to do first, and then the rest can do the thing. Okay. So well, we have to go through all the items, except we can just consider this now. And we're gonna check like if item entity has how to check if it's the player. Well, we can check if it has controllable. We can check if it has player character. I guess that is more better, maybe. I don't know. Let's just check that. If we have a player character among the things that should be doing something now, then we have this thing here. Actually, then we could just return that as like a singular thing. Then we can say like result resize to 1 and just set this to be item. Actually, do that first, because otherwise it might be weird. I don't know. Let's do that. Okay, yeah, I think it will crash actually, otherwise maybe. No, maybe not, because we've copied this item, so I don't think there's an issue there. Yeah, it's a copy, yeah. Okay. Okay. Let's do that anyway. And then we just return the result here. Actually, you know what? We can, if we do an else here, we can actually put u in this. I've never actually used this structure before. I have used for else before, but that is for this purpose, to kind of make a result, because that it's a very good pattern for you know, if you want a one result that you want to be kind of constant, but you have to iterate through something, through a list to do that, and then find something in there, unless, well, or else you do a default value. It's very good for that purpose. I've never used it for this purpose, which is kind of interesting. So it's like, yeah, if we have like the final result, I mean, it's kind of the same, I guess. It's kind of the same. It's just that we have like a common functionality that we don't want to fall through between each one. So what the for else will do is like, it will iterate through this normally. If you break, it won't go into the else, it will continue down here. If you don't break, if the for loop is kind of exhausting all possibilities in this list, it will go into the else. So I think it's a kind of a cool, I've never seen that in another language from what I remember. Yeah, it's the first time I encountered this in Zig here. So yeah, cool. But I will say it's not super easy to kind of reason about. I mean, it is kind of easy to reason about, but it's like, it's at the same time, it's like it's so different from, you know, I don't know, I mean, it's not that different, but it's like, it's a little bit weird to have a for else, you know. It's like if else makes sense, for else, I mean, it kind of makes sense. I guess I'm not used to it most often enough. I usually don't use it, but for certain very specific purposes, I do use it, as you can see here. Anyway, okay, what did we just do? We now should be prioritizing the player. If we find the player within this result, we're gonna just use that player takes precedence, and that is the one that is active. Otherwise, we just take a message. So now I should be able to make 2 moves before I see them make their moves. Yes. Okay, cool. So now I get precedence, which is nice. Okay. Awesome. So, yeah. That's cool. Yeah, so I think that's gonna be it for this time. I think next time we're gonna focus on combat a little bit more. Like I was going to do that this time, but got stuck on a lot of you know, the infrastructure to actually have combat to start with. Like having so what we've done today is basically we've implemented turn-based system so that each entity can move or do their action whenever it's their turn. The AI will do their action and the player will do their action, and the system will wait for them to actually calculate their things and set their actions and stuff. So that is very nice and it works pretty well. And they do their actions at the same time if they have the same turn. Now it's probably gonna be, it works well now when they kind of all have the exact same turn, but it might be different later because the turn is like a floating point number. So you know, it might be, you might still have to wait. Like if we introduce, like, okay, let's do that right now. Actually, let's add, let's make a critter that is, let's actually, well, let's do this. Let's make a fast critter. And I'm going to say, now the fast critter is going to be a hippo. No, I don't know. A crab, an elephant. There's so many things here. Maybe a horse is faster than, or a rabbit than a donkey. I don't know actually. How fast is a donkey? I guess they could be super fast because they are. Or it's not a donkey, it's a llama. Is this, or maybe this is a cow? Is this a horse? Or is it a, I don't know. No, this is a deer, right? This has to be a deer. Okay, but anyway, let's try the horse. This is 1209. So go over to animations. I'll add a horse. I think it's a horse anyway. That's 1209. Okay, so the fast critter is a horse, and it has 2 speed. Actually, yeah, this is going to be interesting to see how this will work, because now it kind of moves faster than the player. So we're creating a fast critter. Let's put it, I guess, over here maybe. Yeah. Or maybe, well, yeah, that's fine. Okay, let's see. It should actually get a turn in before the player can actually do anything. Yeah. So I move. That's gonna do 2 turns. Every time I move, it's doing 2 turns. Okay, well, I mean, it does work. And since their kind of turn number is still, you know, there's no precision issues. So it's still like incremented, even though it's incremented by half, it's still able to kind of go up by 1/2 as a step. So it will match the other creature's speed. Cool. And you know, if you meet a fast enemy, you can kind of imagine that it will hunt you down and start attacking you twice. But I will make it so that different actions will have different times. So even if it has like fast movement speed, maybe the attack is not fast, or the other way around. Maybe it has slow movement speed, but the attack is super fast or something like that. All right. Anyway, yeah. So we did that, and we also imported the state machine system, even though I'm not really using it a lot yet. But I will next time, because next time I'm gonna focus on adding an enemy to attack for a combat system. So that's gonna be great. So yeah, that's it. Thank you very much for watching, and hope you have a nice day. And I'll see you later. Now let's see if we can send you off on Twitch here. Someone actually said I should put English on here. English tag. Maybe I should do that. Put English on there. If other streamers are finding raid targets based on language, maybe it's a good thing to add. I don't remember if I had that. Okay, action RPG. Well, there you go. Although that doesn't look like English. even though it's an English tag. Simple space robots platformer. Hey, here we go. Programming in assembly for the Game Boy. Oh yeah, maybe we'll do some Raylib assembly at some point. All right, but that's gonna be it. Thanks you so much. Start raid. See how many we have. 4. All right. Bye bye.
French.